Right, so welcome to this event. I'm Javier Castañón. I'm the head of ETS here in the AA. And I'd like to welcome everybody, both those of you here and those who are following it online. I think that the title of the event needs a bit of explaining. What's behind it all is that for some time, my colleagues and I in the ETS, the ETS as it used to be, were quite anxious that we should be putting all these topics that we're going to deal today more center stage. And I did approach 3 directors of the AA, one of them interim over here, but saying, look, we need to put all these issues center stage. We need to make a kind of declaration, etc. But I didn't quite have an answer, except for this year, when I asked, and immediately I got a response from Mark Morris saying, yes, and do an event in the open week in the second term. As I say, we were working on this for some time, and funnily enough, very much in the AA style, we got a green light a few years ago from the students because they organized a climate crisis, or no, it was called Climate Summit. And it was a great event. And we understood that that was the students of the AA giving us a great light to go ahead. And since then, we have actually worked on this. We first called it From Now On, meaning that we acknowledged that a lot of the ills of this planet were caused by irresponsible or perhaps not knowledgeable enough work of people. So we were saying, no, up to now we've designed this way. Now, from now on, we're going to design this way. So on a more radical approach to how we can mend this world through our own ordinary work. So this went on for some time. And then now, well, it was suggested, well, if we were called from now on, how about so far? You know, so that's the first part, you know, this is how far we got. But it's not only that, it's more that, see, this event is primarily for the students. And, you know, they get a lot of all these issues are brought up in lecture courses, in seminars. Our lecture courses are more hands-on every time. So there's a one-to-one tradition in the AA. But so all that is, they get it. But what we wanted to do was to look at the practice. And this has a reason as well. Over the last couple of years, you know, of confinement and all that sort of thing, I've attended many symposia and many conferences online. And very often I would say, well, so-and-so in our department knows much more than this person. Or this is so-and-so is actually doing it. So it was a question of saying, look, let's take center stage and let's show that this is possible in practice. So the conversation is very much geared to that, to complement what we're actually dealing with in the lecture courses. So so that's explaining the kind of ideas behind the title. I think we're all committed to make of the AA a seedbed for responsible architects and designers who are well informed, and they know that they can actually turn things around through their work, through their design. So now comes thanking people, and there's a long list, but Kian always cuts me short, so I'll have to be very quick. So I've tried saying it very fast to see if I can say more names, but it's a long, I mean, obviously Nacho, Kieran, Giles have been in the forefront. Joanna, Xavier, Tom, Camilla, Pablo, David, Delfina, Alan, Ioannis, Anna, Tom, Francesco, Laura, Antonio, and it goes on. I like to make a special mention of Anna, who's just jumped in the deep end to help us save one or two little things, one side or the other. And then, of course, all the people that have been invited. It's amazing. We have a great response. Everybody said yes. And then, well, here in the AA, Manager and her team in the public program and the communications and the studio, the AV, where they're hiding behind screens and things and making it all happen. So This is it. It's just putting it in perspective. So I'll let Kieran take on.
Hi everyone. Welcome to our first panel of the day. I'm going to spend our first, which is on environment, and introduce our first speaker, Camilla Rock, an associate at Grimshaw Architects. After you.
Hi everyone, thanks for the invite, Kieran. Today I'm going to be presenting or talking about Eden project, but specifically about Eden Project North, which is our latest Eden project, which is aiming to regenerate and transform the north west of England. And great news, we had planning permission approved last week, so that's always a good sort of start. So for the ones that are not familiar with it, I'll start with a brief intro about Eden Project International, and then take you through the Eden Project North in more detail, focusing on design generation and our regenerative design approach before Kieran stops me. So Eden Project is a social and educational charity that builds relationships between people and the nature, the natural world around them. It started with a transformation of a clay pit that you can see here into one of the most successful visitor education sort of research entertainment destinations here in the UK. Today, Eden Project is working in partnership with different organizations in order to create new Edens and respond to the planetary emergency. And at Grimshaw, we're really lucky to be part of that journey when it comes to design. So it's important to mention here as well that Eden works in different climate, different regions and different cultures, trying to look for, identify where difference can be made in preservation and regeneration of all life through promoting things like biodiversity, responsible water, energy use, circular economies, among others. So now we're going to jump into Eden Project North. Is, as you can see here, located in the Morecambe Bay, so it's the northwest of England, near to Lancaster. The site's been reclaimed many times, as you can see here to the left, and that's what the site looks like today. There is a car park there, it's pretty much abandoned, and there is this amphitheatre, which is basically very sort of, in not a great sort of state. So to develop the architectural concept of the building, we focused on these four key aspects. The architectural, sort of the first part of it, it was having a building that is inspired by nature, specifically the nature of Morecambe Bay. The second aim was to build an exemplar building in terms of sustainability. So in collaboration with our engineers and the consultants partners with us, we're developing regenerative design strategy that is allowing us to develop some kind of like various frameworks and sort of understand how can we make it the best way possible. Then our third ingredient will be experiential design. So Eden Eden North will contain like a series of great experiences, and we're working closely with the experiential team that is at Eden Project, basically, that to ensure that we basically provide the right spaces for them to sort of get these amazing activities that they want to get sorted in the place. And finally, we've been developing, the design according to the site context and also the constraints that we have, seen them as opportunities, and I'll explain these in the next couple of slides. So going back to the first ingredient, certainly a starting point for us was about learning from beauty and efficiency found in nature. So as you can see here, for the ones that are familiar with Cornwall, this is an approach that informs a number of buildings there in Cornwall, and we've believed this will help us to achieve our regenerative design aspirations as well when it comes to Eden North. So we got inspired here by the unique coastal setting, as I said, of Morecambe Bay, and looked at how mussels structure their thin shells, which each layer has a specific sort of way of performing according to a specialized function that allows them to thrive. This is an Eden project, so of course, sustainability has been always at the forefront of our thinking, both for the architecture and for the landscape when it comes to design. The building's being shaped, thinking about how we can imagine things like energy use and embodied carbon, as well as paying specific attention to design for health and wellness, for instance, and of course, how to enhance ecology and biodiversity of the place in a building that hopefully aims to be resilient and highly adaptable to future changes. Third ingredient was the experiential design. So Eden North, in this case, will connect visitors to the natural world around them, focusing on natural rhythms. So there is 5 dominant cycles that have been identified by Eden, and these are cultural rhythms, daily rhythms, tidal rhythms, lunar rhythms, and seasonal rhythms. And this is specifically because when you go to Morecambe, I mean, it's kind of like a great natural environment. And so things like, for instance, the tidal rhythm are very sort of clear when it comes to, to see how they are governed by the sun and the moon. So they thought that it was a really good theme to explore in here. The position of the shells on this site is heavily informed by the site context and the site constraints. So as an example, respecting the natural depression, that is that pink zone that you can see there, was for us a must to minimize digging and relocation of land on site. Also, we try to keep existing structures like the amphitheater as well to decrease like, embodied carbon. And that was like basically a rule that Eden has. And in that case, that helped us to sort of, shape the biggest shell, which is the rhythm machine. That's what they call it. So this is what the current scheme looks like in plan. There are 4 shells located around a central courtyard, which is the Four Seasons Garden located in here. Can you see my cursor, by the way? Yeah. So the main entrance is through the visitor center, which is here, and is at the south, and is next to an Eden Cafe and retail area. The idea here is to have an active frontage towards the town in this promenade here. And the Bay Hall is the first shell located here. So here's where people are going to start on orientating themselves. That they will be introduced to the venue with some kind of very sort of encouraging exhibition. Then we've got the rhythm machine. The rhythm machine, which is the biggest shell, the one that I was just talking about, and that will contain different sort of immersive experiences about life above and below the bay. Next, we've got the Natural Observatory, which points to the north, looking at the Lake District. And this will contain, our science engagement space. So here we paired with University of Lancaster, and they will have a permanent space in here. And that they will be sort of doing different sort of research experiences on different types of exhibitions as well. And here we'll also have some kind of like a seasonal programming space that will contain, the exhibitions from abroad or permanent ones as well. And finally, we've got here the Bay Glade, which is the most transparent and transparent biome at sail. And it's kind of like, for the ones that are familiar to Eden, Cornwall is similar to the Med biome. So it's basically Eden here are planning to have lots of different horticultural sort of exhibits, which what they call an eternal spring, which also paired with some rhythms in nature. So things like, sleeping and all these sort of type of circadian rhythms will be sort of shown and exhibited in here. So in these sections, we can see how the dunescape, sorry, I forgot to mention the dunescape, actually. I'll go back. So in here, all the ancillary spaces around the shells are located in a lower structure that wraps around them, and we call them the dunescape. So here, the idea is to see how this dunescape connects the shells to the ground. We see these as kind of like a landscape roof that undulates, responding to different programmatic requirements and shaping amazing spaces while also trying to enhance local ecology and biodiversity. So this also creates like a seamless integration between the architecture and the external landscape, responding to public areas and to the town itself as well. Here is a view towards the entrance from west, side of the promenade, looking at the public promenade that goes to the town on the main street. And this is a concept image of the whole venue, where it's possible to see also the landscape proposal to the east side. So here we've got what we call the Rhythm Gardens, and it's going to be basically an open air amphitheater that at points is also going to be public for the community and for people around the town. And then to the west, we've got what they call the tide gardens that are connected to like an underground level tidal pools that we've got here in the river machine. And the idea is also that, you know, the whole landscape is also integrated into the building itself. And then in this area here is what we call the energy field. And I'll tell you a little bit more about it in a couple of slides. Then when it goes towards regenerative design, now if we zoom out a bit, the project aims not only to keep the environmental impact to an absolute maximum, but actually deliver like environmental benefits that drive changes that go beyond the boundaries of the project. So to support this process, a framework based on natural capitals like biodiversity, materials, water, energy, waste, among others, will be, as well as wider issues like the human, social aspect of things, manufacture, and even the finite. Okay, go like 2 more slides again. Have been developed by Eden and another consultant. So these are the ones that we've been using to develop this project. And now, if we ask ourselves, how does the scheme currently respond to this approach towards regenerative sustainability? Picking up on the design principles I mentioned earlier, here are some of the initiatives that we're proposing and hope to materialize. So one of the things like use biomimicry in architecture, for instance, a design that is inspired by nature, where architecture is actually in harmony with the bay, like a colony of shells, like nestling on this dunescape by the bay. Design for health and wellness, like, you know, the connection to the outside world. Biophilic design is very important for us. Beauty, like, you know, it's super important that we end up with a beautiful outcome that sort of have this health and wellness for people, like, you know, that like to be in there. Universal access and inclusion is also like a very important part, as well as the education and being very inspirational. We've also been looking at how to minimize body carbon by, you know, choice of materials, being resilient and adaptable by, you know, working with the structural engineers very closely on adaptability to future climate change. Minimize operational energy, for instance, by, like, you know, having passive design principles that as a priority for design, maximizing daylight, minimizing solar gain. And also we've got this variable like thermal environment that, you know, relates closely to thermal comfort, where we've decided like that the grid shell is softly conditioned. So you have a greater temperature range in it, but then some other spaces in the dunescape below will be tidally and heavily insulated. One more slide and that's it. Improve on-site water management is also something very important, as well as minimize carbon in energy supply and in the value chain. So using, for instance, ground source heat pumps or air source heat pumps as well. And, you know, the dunescape, as I said, it will sort of be enhancing ecology and biodiversity. And here's the energy field. So essentially, the idea of this space here that is in front of the town itself, and I wrap up here, is to express this regenerative design approach of the building and the landscape as an educational tool. So essentially what's going to happen here is that people are going to go through, they're going to see all these like PV integration to the south of the facade up here, or, you know, the heat pumps technologies being installed in here, and they wondered themselves, what is this, you know, like, and that will be like a big story that Eden was sort of telling them and say, look, this is here because we are in a planetary emergency, and this is how the building is actually showcasing and contributing to this commitment of, you know, like decreasing or going towards net zero or regenerative design. So I think it was more than 10 minutes, but that's it. I'm sorry about that, but it's just like a big project. So, you know, couldn't do it faster.
Thank you. For our next presentation, I'm going to invite Alan Harris, Director at Integration, and Ioannis Rizos from Atelier 10.
Thanks, Kieran. So my name is Alan Harris. Good morning, everyone. I'm from Integration, Building Services Engineers. I'm joined by Ioannis Rizos from Atelier 10. And today we're going to talk about integrated environmental design. So this is the framework that we use at Integration to train our engineers in environmental design. Covers building form, building envelope, building services, renewables, lots of different interventions to improve natural ventilation and daylight, etc. Not going to go into this today. What we really want to do is talk about the challenges to integrating these different interventions. So I've outlined 3 different challenges here. The first one is energy use versus health and well-being. For example, you might want to have more fresh air in your building, but then of course you need more fan power. You have to preheat that in winter. You might want better daylight, but then of course you need bigger windows that are letting more heat out. Operational energy versus embodied energy. For example, you might want to design out active cooling using thermal mass, but of course you've got embodied energy there. Or, for example, you might want to have more insulation, but of course you've got embodied energy costs as well. And the main one really is cost versus sustainability, because of the developers' drive for cost efficiency. So the way we approach this, the way we tackle these challenges is through what we call integrated environmental design. And it's really about expanding your horizons. And I quite like this quote here from Dwight Eisenhower, the former US president. He says, if a problem can't be solved, enlarge it. So to do that, we have two basic steps. One is identifying needs, that can be local stakeholder needs or much wider society needs. And then the second step really is creating value. So you design to create as much value as you can, to design solutions to meet as many needs as you possibly can. So what do I mean by needs? Here are some simple examples. We've got health and well-being needs, social needs, infrastructure needs. For example, the NHS spends about £200 million a year. A big proportion of that is spent on diabetes. Type 2 diabetes is a massive issue, affects about 40% of the UK. It's a lifestyle disease from lack of exercise or poor diet choices. Mental health is another issue as well. That costs the country about £100 billion a year. Social needs, for example, looking after the elderly. Fuel poverty is another one that affects about 10% of the UK. So officially about 2.5 million homes are classed as being under fuel poverty, so-called heat or eat. National Grid, for example, they're trying to be zero carbon by 2050. They've got about 30 gigawatts of offshore wind going in the next few years. They've got to integrate electric vehicles, electric heating. They've got a big challenge ahead of them. They need designers to work with them to use energy flexibly. On the environment, for example, lots and lots of different challenges, for example, soil health degradation, pollinators, biodiversity. So here is a very, very simple example of what this might look like. Here we've got a residential block in the UK context, and this is what we call a generous stair core, which is fully glazed. It's letting in a lot of sun. So we're maximizing our passive solar gains. This is reducing the heat loss to the buildings, the apartments adjacent to the stair core. And of course, it lets you preheat your fresh air before it goes into your apartments. And then we're maximizing our solar PV density on top. That reduces the cost and as well as reducing your energy bills. We have a centralized heat pump with an energy store. So we're working with National Grid to be flexible with our energy. And rather than buying a separate battery, we're working with cars and vehicle to grid. So this also gives us lots of opportunities to integrate health and well-being aspects. For example, you're giving opportunities for people to go into the sun, get 20 minutes a day, make sure they're getting their vitamin D. Most people in the UK are chronically short of vitamin D. And we've got opportunities to create playful sensory spaces that are engaging, that have seasonal scents and colors, dynamic lights. Lots of opportunities for food growing, different scales, for example, tree scales, like growing avocados, or on your balcony, having a balcony box to grow your leafy greens, make sure you get your magnesium. And then integrating social spaces as well, areas that you can go to meditate or meet socially, and having active design integrated into that as well. For example, making a feature out of your stairs, having spaces dedicated for exercise, and making a feature out of cycle storage, not just having storage in the basement, but actually making a feature out of that.
So integrated environmental design is about identifying and addressing what makes sense. And what really makes sense is to minimize our reliance upon natural resources, be it energy, materials, water, so be it. So here's what we found in our day-to-day practice. We found that building form really matters. We found that building form really matters. Its compact forms are better from an embodied carbon and operational carbon perspective. We've also found that materiality really matters. We tend to specify aluminium as the first call of choice for facades, for example, but there is a huge range of material palette with really impressive life cycle properties across. we found that structural systems matter significantly. We found that timber frame and CLT structures are really good in terms of embodied carbon when it comes to shorter grids. But when it comes to larger grids, post-tension structures and RC frames really kind of deliver more. Not surprisingly, we found that the size of the structural grid really matters, with smaller grids, of course, kind of being much better than bigger grids, which essentially leads to us designers and the real estate industry as a whole start thinking about, like, we really need to start liking columns if we were to tackle the whole commerciality versus sustainability argument. Another thing we found was the retaining existing parts of the building matters. If we make active effort, and I mean active effort, to retain parts of existing structures, then that can yield significant benefits. Of course, that may not be applicable all the time in all locations around the world. Last but not least, an interesting point we found is that within the context of a decarbonizing grid, we found that adding more insulation actually adds more carbon, or it's likely to add more carbon. Why? Again, and you really need to approach that with a pinch of salt. So essentially, some extruded insulation products out there are essentially really heavy, really dense on embodied carbon. So if you're trying to meet building regulations or local planning kind of requirements, with adding more insulation, you may end up adding more carbon in the whole story. Over to you, Alan.
So in terms of our challenges, for example, energy use versus health and well-being, it's not just looking at daylight, for example, or making sure you've got enough fresh air. There are wider things we need to consider as well. For example, incorporating active design, encouraging food growing and healthy nutrition, giving people access to sun spaces, whether that's internally or externally, is really important. And then, of course, making sure that communities have got spaces to come together. And in terms of operational energy versus embodied energy, as Yanis has mentioned, reducing material use, rationalization of insulation, using smaller structural grids, and reusing existing structures where you can. And then in terms of cost versus sustainability, I think the most important thing is trying to create value. For example, you can design a building just to provide an apartment to someone, or you can design a building to provide an apartment or a space that offers a whole lot of health benefits, financial benefits like reduced bills, demand side response income, free facilities, free community facilities, lower transport costs, food growing opportunities, and of course, reduced health costs, as well as wider impacts like reducing emissions and improving ecosystem services like pollinators and supporting a zero carbon grid. So just to conclude, we think that integrated environmental design can be regenerative. I think it's good to keep in mind that it's quite difficult for someone to be an active part of their community or to really care about climate change if, for example, they've got physical health issues, mental health issues, or financial issues. So what we're trying to do really is create freedoms for people to become active members in their community and contribute to action on climate change. Thank you.
Thank you guys for that wonderful presentation. I would like to next invite, sorry, one second. Joana Carla Soares Conclaves, a researcher and environmental consultant, and Eduardo Pizarro, architect and researcher, who will be joining us remotely via Zoom.
Good morning, everybody. I'm Joana, and I would like to introduce my friend Eduardo, who is already online. I mean, Kieran has introduced us. I would like to call Edu and ask him to come to the virtual stage and start the talk.
So thank you very much again. It's a pleasure to be here. Good morning to everyone. Thanks, Joe. So straight to the point, we focus our project in favelas in São Paulo. I can see is the slides working? Yeah. Yeah. So we focus our project in favelas. And this is the second largest favela in the city of São Paulo. It's called Paraisópolis. It has around 100,000 inhabitants, so it's big, it's not small. And despite the infrastructural shortages, it's a consolidated reality, mostly self-built. the rooftop is the most important part of the favela because it plays an important role for the shared spaces despite the inefficient shading. And the building is marked by poor environmental conditions indoors due to the building fabric, which is underperformative, and inefficient openings.
And now I'm stepping in. We should consider that São Paulo is a city of subtropical climate with very long periods of hot, humid conditions. And we went on site to understand what's the performance of these homes that so many thousands of people are living in. And Paraisópolis is just an example of a wide Brazilian reality, including the building form and the way buildings are built. So first we did some field work and we identified internal temperatures almost 4 or 5 degrees higher than the external ones on a typical summer day, warm and humid. Not so hot though, but still warm and humid. Now we moved to then an analytical kind of studies, and we went to explore what the effect of just a double opening or using the whole area of the window for ventilation, what would be the effect of that. And we identified a reduction in internal peak temperatures by 2 degrees. And then we went a bit further and said, okay, so we definitely need ventilation. Ventilation is doing something for us here, removing this heat. So what if the whole facade is a ventilated or ventilating area? Of course, with shading, remember we are in the tropics. So shading is a must and ventilation is definitely desirable and can do a lot for internal conditions. And looking at the legacy of Brazilian bioclimatic modernism, we have loads of examples and on how to do that, how to achieve a combined integrated, to borrow the words from Alan and Yanis, an integrated solution of shading and ventilation. And this is a beautiful scheme, is the Parque Gingley development designed by Lúcio Costa in Rio de Janeiro. But how can we then interpret this tradition in something that will have the identity of the informal city, of the favelas, something that could be ordinary, meaning common to them, familiar to those who are there, replicable, so we would have a big social and economic impact as well, and a wide environmental impact. Again, something local to reduce all sorts of impact, including transportation of materials, and something that you could do it yourself. Otherwise, it's not going to happen, and it's not going to happen at the scale that we want. So the second question, well, then with these questions in mind, we went on site again and said, which are the typical materials? Let's start from element number 1. And of course, the brick is there, hollow ceramic blocks, but also concrete hollow blocks and the solid brick. But how can we make this into a design? And then we went back to very basic low-tech design strategy, which was just looking at the different facades, the shading requirements that different orientations would have, and how with those elements we could then redesign the facades completely to provide what we wanted, the ventilation and the shading. And then thinking of the applicability of these general guidelines, how could then this facade be a true interface between inside and outside, creating living spaces, doing more than just performance? So there were different speculations. We had a lot of fun designing those, imagining how people could use and apply. So then comes the design and build. Considering the design and build, we had a dual approach. Like Eduardo said in the beginning, the rooftop, the slabs is a big space, or it's a big, it's something very important in the environment of the favelas. So, but the first one was then, going back to the facade design. So the first approach was approaching the facade. So removing everything, including some polycarbonate panels that could open and close, as we also have winter conditions when we would need to control this ventilation, and then coming with the screens. And this could modify a lot the buildscape without transforming the built environment. And then the second approach would be looking at the rooftops again, and creating a more efficient shading that doesn't necessarily come from a horizontal plan that projects itself exactly over the area of the roof, but something that could really block the sun and keep the ventilation going. So again, we thought of applicability, opportunities, possibilities, And remembering that considering that the rooftop is an extension of the house, is a communal space, is also a private space. And in the climate, in the subtropical conditions of São Paulo, is a space that if it's well shaded and ventilated could be used for most of the year. And then we transform into this design with proper guidelines, looking again at different orientations. So this will be a way of doing the north orientation. Remember, we are now in the rooftops, or the west, much more closed, or the south, more open, but still shaded. And the east, we kept it open because the sun in the morning is always welcome for so many reasons. And if we are ventilated, why not? And we like to sunbathe. So now going on site.
Going on site, the community leader asked us to go and build a prototype on the rooftop of the community center. So there you can see a small pavilion on the previous slide, where they serve food as part of the kitchen school. And on the next slide, we can see the different screens depending on the solar orientation. And at the next slides, we see some pictures of the building process with the participation of local labor. It was fun. It was very simple, very interesting, the whole process. And we can also see the space and the screens being colonized. And from this whole process, we could see one of the most important part of the process was to posters. So these posters on the next slides are supposed to share some very simple environmental guidelines to inform the local community to build in a better way. On the right-hand side, you can see the schemes for building the screens, depending on the solar orientation. But how can we easily disseminate this basic technical knowledge? On the next slide, we see a picture of the community center with the intervention on the top. And if we go around the corner, we see this. Yeah. So it's happening, it's starting to disseminate. But even like that, how could we reach even further regarding the territory and broaden regarding the technical scope? Then to respond to this demand, we created a digital platform entitled Change or Mood. And it is structured by step-by-step schemes, very simple, very ordinary, regarding protection against heat, promotion of daylight, and natural ventilation. So the different approaches shared with people, not just from Paraisópolis, from the favela, but for different self-built neighborhoods. And on the next slides, you can have access to the platform. And to conclude, during this whole process, we hope to assist the community, the local community, reshaping its built environment and improving the quality of living space. That's it. Thank you. Joe, want to add something?
No, thank you, Eduardo. You said it all. Thank you, Kieran.
Thank you. Thank you for that wonderful presentation. I'm going to welcome our last presenter, Francesco Anselmo, technical program manager at Google.
Hello, everyone. Thank you, Kieran, for the introduction. So, yeah, my name is Francesco Anselmo. I currently affiliated with Google, where I work on very active buildings. So, what I'm going to talk about today is the opposite. Actually, is maybe the ultimate passive building. I work on this project while I was working at Arup, so which is one of the partners who helped develop this project. So Arup did the engineering, the architecture, that is Lang the project management, and the client facilitator was Cybertrat. Actually, the ultimate client was the local community. A little preamble before I start. So 10 years ago, I was asked in a conversation by a partner at a big architectural practice, what is the project that you like the most, the one that you are most proud of? And I show this project and I was easily dismissed because it's looking like a shed, and but there is much more out of this project than what it might look like or maybe deceiving. A bit like the project that Joanna and Eduardo presented, it has some similar themes. So today I've got this possibility of turning this into an argument maybe for better architecture. The project is located in Ghana, so it's actually the first of a series of kindergarten, so for pre-primary education that have been now developed. And it was the prototype garden built in Douabor. So this is the Douabor village. So you get an idea of the local construction situation, residential in this case. The government had started changing the rules for education, so pre-primary education in Ghana, and starting a program. And the situations that we found, that was there, that the Sabre Trust found, was quite depressing, with the kids, not liking the classrooms because it rains. If you read the story on the left, tin roof leaks are only two sides, and they get wet. There is a school when the rain comes, there are only two sides of my classroom. The light shines in my eyes, there is dust, and teacher stories with, for instance, more than 70 pupils in the same rooms. So we were there to really try and change this. Government schools were started to be built, but they were built with, not the best engineering practices. Essentially, there were solar cookers, dark inside, small windows, noisy, especially when raining, with this big metal roofs, and quite leaky as well. So there are, I split my presentation into four main parts. So the first part is really about the process of designing. And so the design with the community, the possibility of speaking with the elders in the village, with the teachers there, and the planning actually with in physical terms, the layout of the place, understanding how the community can actually help as well, mapping the shape of the school was a very important part, and it actually the realization of this was the master planning of the entire school, which is located on top of a small hill very close to the village, and it includes all the facilities that can help the school. So from the left you see store and kitchen, then you see the main classrooms, and on the right you see the toilets, and bridge planting outside, and then outside teaching areas as well, which complement the space. So there are three main classrooms in this particular case, each one with a special age group connected to that. You also actually can notice the clear orientation north-south with the two main sort of exposures, which we gave with a little bit of flexibility for construction in other sites, but essentially was very, very well used in this particular location. And also the simplicity of the design itself. Essentially it's a big roof which can collect water, and a simple concrete structure, and a large space. The space is dually lit, so north and south. And the span is about 8 meters in width, so 12 meters in depth, which makes the perfect size for the particular group. It can be split into two parts for two groups of children. So there are a lot of consideration about how it is used. So this is what one part of the initial development looks like when it was just about to open. And it's one aspect of it, being built with the community. It is a resilient space that can be used for other activities, by the community itself. If there are issues, maybe environmental issues, maybe like seismic events and so on, this provides really a resilient place for everyone to use. The other aspect that was interesting was the use of local resources. So we spent time really trying to understand the best technology, and one part of that is because there are so few, so many constraints in terms of making it work financially. getting it right from the overall holistic perspective was complicated, and actually using industrialized materials versus local materials was one of the big challenges. And actually, I think we really get it right by using bamboo, coconut husks as materials to provide very, very important components to it. So I'll talk now about the structure. So the structure provides a safe frame, and so you see the foundation work in this case. You also see the people working are part of the community itself. So there was this possibility of upskilling the local team. So it was a mix of the professional and the people developing skills were then be able to be employed as well in the next projects. So you see a little bit more development here in the structure and the roof coming up, the walls. So the concrete was was actually more sustainable than the most sustainable option that we can. So we were able to made pozzolana from fire palm kernels, and we substituted Portland cement in this case. And so lowering a lot first lowering transport carbon emissions and so on, but also being able to develop a particular construction method that is connected to the local environment. The other success story on the structural side was the use of soil stabilized mud cement blocks, and so these blocks were perceived to be a poor man way of building, but actually we proved that they have twice the strength of the locally sourced blocks. So there is an interesting story here that sometimes looks can be deceiving, and actually something that is more sustainable can also be more performing. The environmental story is also quite rich. So you see the interior of the final classroom here with perfect environment for teaching. How do we achieve this? Obviously, looking at the environment is quite similar to the one that John and Eduardo showed is subtropical. You see the path of the sun from east to west, quite consistent throughout the year. A clear rainy season. It's quite hot and humid environment. So the importance of ventilation, air circulation, and the importance of shading is very clear. So this sketch summarizes the entire environmental approach, and so providing shelter while keeping the environment quiet, providing circulation, the light without direct sunlight, and making the surfaces as cool as possible, so to avoid radiation. And this was achieved obviously with the orientation by using shading, by adding also insulation for both noise and heat, and that is the story that I started highlighting before with the coconut husk. So you see here, the material, being created. This was quite an interesting way of creating it. The entire community was asked to come together. There were 2 football teams, and there were sort of a little event was created to see how much each one could create, and put it into this sort of bags, and then fixed onto the roof. And they really work. They really make the environment very quiet when it rains, and not hot at all. The lighting strategy, very simple as well. The idea is essentially providing all the shading and using the inter-reflected component of light from the outside, and this is achieved by using this rotating window frame, which I think is one of the innovation of the project. Again, you see very simple shading diagrams which show that with the overhang and with the tilting frame, you can achieve a perfect total shading. We left, and this is validated as well by using simulation. In this case, the use of a novel metric called useful daylight illuminance, which in this case shows that there are perfect illumination condition. We provided that target between 300 and 3,000 lux, and you can see it easier. Other simulation that show it more visually, and so a bit of detailing. So ventilation, we painted the ceiling white just to make it, and this provides a perfect diffuse illumination. You see a few more details in this case as well of the rotating elements. It was all built locally with bamboo. So again, another way of upskilling. And yeah, you see some of the detailing as well inside, which make the space very, very well utilized. Sanitation was also quite important. Very quick story. I think I'm going to summarize it quickly with, the roof itself. That's the reason why the shape is this, is so that you can maximize on one slope the collection of water. It is a hot surface, so no bacteria come, and then each one of the roof has its own collector, and is used obviously locally for the needs of the kitchen and any other sort of sanitation user. So the education part at the end is what this whole thing was built for, and so you can see how the spaces can be used and how kids learn. There are outdoor spaces which are also sheltered, so kids can play outside in the shade of the sun, and they can use they're used by the community for events. Post-occupancy evaluation was also made, which kind of taught in very simple terms we gathered positive results from the community, and the good story is that 17 more of the schools have been built since the time. And if you want to know a little bit more, there is a good YouTube video you can go, and there is a good article as well you can read as well. So thank you so much.
Thank you. So thank you very much for that presentation. I'm going to invite all of the presenters to come join me at the front, and then I'm going to invite our respondents to, first of all, ask or provide their commentary on what they've seen so far. So thank you very much. So we have a couple of people who have asked to join us to respond to these, to respond to what they've seen. We have Anna Save and Franklin Lee from architects from Sub-DV Architectural Practice. We also have Alistair Ben Dixon, architect and co-founder of The Collective Works. So I think Anna and Franklin are joining us remotely. If they wouldn't mind unmuting them. If Anna would like to go first. Yeah.
Hello.
Hi.
Hi, can you hear me?
Yep.
Great. Was very, when you said Anna, did you mean me, Anne, or another Anna?
Oh, sorry, yeah.
Okay, perfect. Now, I'd like to, I'm very inspired by the 4 presentations that really encompass different scales and different contexts. But one overlying theme was the idea of replication and dissemination of certain pilot projects or prototypes, and how they get, how one is able to bring it to a larger body of people. So I was very interested to see that in the Eden project, for example, that there is a concept design for some internet Edens to take throughout the world in different contexts, in Sequoia and different parts of the world. For the project in Persuasive, I think it was very interesting to see that there was a very clear guideline to how people can replicate and disseminate the projects, and that people could actually build it themselves. It was interesting at the end to see at even the kindergarten that 17 more have been built. So I guess the question is for maybe each of the presenters, the relationship between the prototype and the pilot and the satellites, the flagship and the satellites. So is it a hierarchical relationship where one maintains a certain amount of control and sort of center of information, or is it more like a rhizomatic relationship where people kind of develop on their own? So I guess potentially maybe, since it was just really quickly touched upon, maybe starting with the kindergarten project, like how was it replicated? What was the agencies involved that replicated the project? Was it exactly the same? How did it change? So more, it's just talking about the pilots and the prototypes, and let's say the repetitions.
Yeah, sure. Yeah. So since the onset, it was very important to think of it as a prototype, and so the way we sort of summarized the design, we did the post-occupancy evaluation to learn back and improve, and then we created a design manual And this design manual is a very kind of pictorial book that can be used by the local teams then to build and amplify the project itself. So I think the communication part was very important, and it was accomplished by creating this book essentially that then the various teams can use. The other way of doing that was really the upskilling of the local community, and the team in Duabor who started building it then was employed in Ayensudo, which was the village and so on. And so there was this aspect of knowledge sharing, and that was really key to the success of the project itself. Also, the partnership with the local government, the kind of proving that there is a better way of building, was another aspect there. And so, I mean, it really goes down to how good this charity is, as well in establishing links. So, I mean, they've been amazing. Obviously, we've made our best from an engineering and design perspective, but there is a lot about the social, connection to the community there that really made a difference. So, yeah, I think these were the aspects of replicability that we applied. I mean, I saw something similar as well in Joanna with the poster. So I think that is, maybe the difference between our project was that there was more of an educational framework around it. Well, in your case, it's really like a creative community. I don't know. Maybe you can expand on this. I don't know. Yeah.
Should I go speak to that?
Yeah. Okay. So I jump in. Yes, Francesco, absolutely. I thought the same when I saw your presentation. There was a difference between the two. What Anne was raising about the question about the replicability and maybe even the efficiency of the prototype or the pilot project. Something that we are still about to see in the Brazilian experiment is that, like you observed, Francesco, the communities are very creative, and they don't want too many rules. So what I think we need because of that, we've seen applications of the basic idea, which different from our guidelines. And something that I want we want to test technically is what is the performance of those variations and how much more free can we be, because they would not follow from close. That's a fact. So what is the minimum framework that we can offer? And it goes beyond the screen. And that's why we went also to aspects of, the internal colors. When they have a little bit of budget to improve their homes, they're not going to render from outside. They're going to do the inside, and they're going to use colors. So what is the impact of colors? What kind of window frames are available in the market that maybe would offer a bigger opening? So we are in that process now of expanding the scope. But yes, I think in our case, because it's also not a public building, it's absolutely minimum guidelines to allow the performance and the quality. I don't know if I respond to your answer, Anne. But
yeah, no, it's interesting to see the different ways that it's disseminated. That there is this manual for the kindergarten, and the same group of people were going in and building the other. So it sort of has like much like Persuasive project. I think there's kind of like a regional aspect, a way that you can repeat on the regional level. And then I guess the question is repetition and dissemination a certain issue about scale. For example, how does Eden work with it, or what are the ideas behind the Eden project? Because their idea was to spread beyond the region, but internationally to completely different parts of the world. Like what is the relationship between the Eden in Cornwall and the potential Edens in other parts of the world?
Camilla, do you want to speak to that?
Yeah, sure. So it's very interesting, like when you see this, it's okay, scaled up in a public project like ours. So to start with, from the architectural sort of design perspective, we've got the framework that I was just taking you through earlier. But then the most interesting part comes when Eden sort of steps into each of the communities. They do an amazing work like that. They really like get into the communities and have something that are community talks that you can actually see on the webpage. And so for Eden North, we have different themes I think it was every Friday that they were doing it, engaging with the community. And so I even had to go one day and sort of present to them the scheme, and they were like, coming back to us and giving us feedback about like, what do they feel or what do they need in the area specifically according to the themes and everything. And very like funny enough, the most interesting questions always came from them rather than from the technical sort of experts. And that's very encouraging because it keeps us sort of close to them and close to the community. Now, when it comes to spreading this into different sort of parts of the world, I think Eden has these sort of framework or this set of principles that they would like to expand in the different locations where they are, but they also have, as I said, this very specific and local sort of aim to sort of get into the community, dig in there. And so the idea, for instance, for the one that we're building in Qingdao at the moment, is not that the people from Cornwall goes and manage it there. The idea is that people over there are coming here and they are educated in the Eden way. And that's the hope that then they go back and start spreading these seeds. So that's basically more or less how it works from a design perspective, but also from a humanistic sort of Eden perspective. I don't know if that answers the question.
Yeah, I was curious about the Eden project. It is like in a sense, a kind of a rural project, and how does the information learned in the rural spread to use in potential urban or suburban conditions, or how is that dissemination? I saw that there's this big lunch idea that people are creating these community that started, I think, in like 2009, 2010. That different ways of how it goes from the rural to potentially things that people can use on a day-to-day basis. Like, what is the definition of community? Is it the community around Cornwall, or is it like larger communities even throughout England?
Thank you, Anne. I'm going to ask Franklin if he'd also jump in. You're going to have to unmute yourself, Franklin.
Hi.
Thanks.
On the Eden project, I'm actually curious to Camila start to talk about, just to explain a little bit, the development from the first Cornwall to the north. Why don't we just point out some differences on the project from this learning, and also from the Persuasive project. I'll say it will be interesting to see you guys started, Joanna and Eduardo, from the roof. And so it's a top-down approach that could affect or has already affected the rooms below in terms of usability. So just to explain a little bit whether that has been affected, the floors below, and starting from the roof to the bottom. Thank you.
Thanks for that. So the first, I'm just going to link this to the previous question, because basically Eden Project North will be the first one around an urban environment. So it's just in the middle of the Morecambe town. And that makes a big difference to the one in Cornwall, which is a site that was like abandoned and there's nothing around it. Here we've got a town to deal with. And so this is the main reason of why we've sort of, Eden has paired with the Lancaster University. So the focus of this Eden will be like, Eden Cornwall also has a big educational sort of impact in the area where they are, but the focus in here will be way more closer to, let's say, research and serious sort of engagement with University on Lancaster. They're going to have, for the first time, the university will be there based in the what we call the Natural Observatory, which was one of the shells. I don't know if you remember the one that points to the north. So for more like an Eden perspective, that will be kind of like a big difference. Now, in terms of design, well, I mean, Eden North, so we've basically in the design generation taken it really as a kind of like an interface between the bay and the natural sort of scape of the, let's say, the bayscape. That's what we call the bayscape, between that and the town. And so how this project sort of becomes an icon in the place where it's placed, surrounded by 3 listed 2 buildings. From an architectural point of view, that is very important. So in a way, the way the shells are kind of arranged on site, and you know how we've been able to sort of keep the views out and you know, like keep the main sort of urban say environment and the urban tissue and enhance it in a way with the coming of this project, is also been, from an architectural perspective, a very challenging sort of goal. And well, thanks God we got there, because last week we got planning permission. So, you know, like it seemed to work.
Great.
Okay, so I jump to my answer. Franklin, thanks for that question. Really interesting, and it gives us the chance to elaborate a little bit more on the project. We started from the roof first because you didn't ask why, but just to clarify, because it was just easier. We tried to find opportunities to work on facade projects. But we found we even had one. We started designing, but then we found quite a lot of resistance halfway through the design process for several reasons. One of them is, I think, culturally in the communities, people understand that kind of facade with the perforated ceramic block that we call in Brazil cobogó, more of a common design for kitchens and bathrooms and sorry, not the bathroom, the whole facade perforated, but parts of it for constant ventilation, laundry areas, but they don't associate that image with the living space. And that's something we would like to change and try to, whereas in the legacy, in the modernist buildings, we see exactly that. So it's the inverted insertion of the material. So that's a cultural change, not a cultural change, but a cultural factor that we are finding as a resistant parameter to change the homes. I'm not sure if this is exactly what you're asking. So we are trying still, and we are working with some families and see what we can do. Even if we start by applying in the kitchen area and then expanding to the living, there are opportunities there. Now, what we have seen is verandas being built with the idea of the screen. Not with the idea of a solid wall, which tells us something. They are reading, they are observing and applying in their way, of course, always in their own way. So there is a challenge there to increase the facade project.
Thanks very much.
Thank you. No, I think it answers the question, right? I think it is approach that can disseminate and go towards bottom, right? And I think the criticism here is not that it started from the roof. I think it's great that it started from the roof and then how it goes down. Great.
Thanks. Before I jump to our last respondent, I'm just going to answer one question that was in the chat. Michelle has asked Alan and Jonas, could you elaborate on how the structural system impacts on the embodied carbon, as in more columns equals energy savings?
Sure. Essentially, that comes out of some of the studies we have done over the last year or so. The bottom line there is that in order to span more on a structural grid, you need more material. You need your columns to be thicker, and that has more material in it, which may not necessarily be working as efficiently as in a smaller grids. And that's one of the reasons. There. Yeah.
Cool. Thank you. All right. So I'm going to jump to Alistair, our last respondent for this panel.
Hi. Thanks very much, everybody, and thank you for the invite. I think it's a fantastic panel, completely inspiring. I'd like to applaud the kind of on the first hand, discussing regenerative design openly, what it means, how do we achieve it, what are the metrics that you need to look at, and so great to see Camilla presenting that so clearly and sharing that process. It takes clearly a long time to develop a project at such scale. So what I'd really like to talk about is, obviously there's different scales across the projects, but I think the speed is interesting because actually the time it takes to develop a project such as Eden, I think the original Eden project is one of the original examples of regenerative design, because what it did for that clay pit is arguably regenerative on that scale, and what it did locally and socially for the cause. But I think what's interesting now is there's a role in advocating for a national sort of retrofit strategy with the sort of the third and fourth projects that we discussed. I guess my question then comes to kind of Alan and Ioannis, given that speed is so important to some projects, like we need a national retrofit strategy quickly. We look to the projects that we've seen as great ideas, great pilots for that. But when it comes to projects such as Eden, the time it takes to figure out all of the complexity in that project, do those kind of projects need to slow down and other kind of projects need to speed up? And how do you manage that sort of speed in projects?
Alan, do you want to go first?
Sure. So I spoke about a number of challenges to bringing these sort of ideas into design. And one of the challenges that I didn't mention is just the amount of work that you have to do to realize a project, and how everyone is very busy. And that is a genuine problem. And I think there's been a big shift in the last sort of recent times, in the last year or so, with people that are sort of bringing more effort and coming together around these ideas, like introducing health and well-being ideas, and thinking about the bigger picture. And I think there is so much to do to realize a building, and it just takes, I think, teamwork for everyone to come together to do it, and meet that demanding timescale that you have. It's not easy, but I do see a genuine change in design teams, the way they're interacting, where people are really pulling together to do that.
So you think collaboration is stronger at the moment, and do you think we should be introducing more stakeholders into the construction industry? Should we be looking at more of the natural environment, more of the animals available on site through planning? So obviously planning on Eden took quite some time. Should there be more stakeholders involved?
Definitely.
Public schemes?
Yeah, the community is a big part of change and regenerative design. So, they have to be really involved in a very serious way. And it's something that is generally neglected. So yeah, that's definitely an area of attention that needs to happen.
Camilla, do you want to comment from the Eden project?
Yeah, I just wanted to finish what I couldn't for Franklin just in 1 second. So Franklin, what I want to say in terms of materials, there's also something that we've been looking at changing from Cornwall to now. Like now we're aiming to have a big a timber grid shell, long span, which is like a big challenge at the moment. And also like having 2022 sort of tech on what it was ETFE by then, and now we're integrating PVs into it. So, from a materials perspective, that's also something that very challenging we're looking at the moment, as well as different technologies on different parts. Now, coming to collaboration, well, it's been such a long process, and we always sort of tend to we've got our team of consultants on the one hand, but also I always sort of get in touch with research and universities, which we find that are very crucial for this. Different organizations that are looking at sustainable steel, for instance, or even entities like, how material system being built at the moment, different technologies, for instance, working on concrete, which is making the University of Manchester, that working with these graphene technologies that, will get a greener concrete, if you like, because, ultimately the project, we know that we'll have to sort of have some concrete into it as much as we didn't like to, but, foundations and that. So looking for the best technologies that, even if they are at a research sort of perspective, I find it really important and really intriguing from that sort of side of collaboration. It's not just the normal technical consultants, but also, what's being done, what's being researched at the moment. It's something that we've been working and collaborating with Eden team very closely as well. I don't know if that answers the question.
Yeah, totally. What I hear is that it's by slowing down the design process, because of all the stakeholders required through planning, actually the design is becoming more sustainable because the technologies are becoming available.
Exactly.
So actually maybe building it 5 years later was a better thing for the project.
That's exactly it, yeah.
But I think we can argue the opposite for the cases of retrofit, because actually there's people in conditions who need far better environments quickly. Mm-hmm. And so there's a real question here about how you do, because I don't know if there's been whole life carbon done on the retrofit projects, because that might tell you that actually some of these things need to be done more slowly to figure that out, because if the unintended consequences aren't quite right, in our case at the moment, there's lots of things that haven't been sort of, or they're in the process of being discovered, or, of being available commercially, for instance, that this graphene, for instance, in the concrete thing, it's a material that's being developed at the moment. And so we're hoping that we could make some use of that later, or even, for instance, for the external walls, we're looking at having the specific material that's being researched at the moment on crushed shells. And so they make walls out of it. And that's also, I can't remember really the universities researching on that, but, we're absolutely interested on all these new sort of materials that are being developed at the moment, and sort of try to get them into the project as soon as they're commercially available. Thank you very much.
Thanks. We're getting to our time. Is there anything that you guys would like to say before we close this panel?
Maybe just a very quick comment. about all projects I see, reflecting on everything we heard, one thing that is definitely important to my project and Eduardo, and I think it applies to others, is trying to do the best we can and revigorate, regenerate, restore, whatever word we want to use, with the absolute minimum resources and understanding the constraints of the context. And sometimes, it's just a brick. Sometimes it's using the sun very well beyond performance, but still minimizing our impact by using less. Yeah, that's something I didn't say in the presentation, and I thought it was important.
Makes sense.
Yeah,
agreed.
Just one more point from me. I mentioned health and well-being. And I think, generally it's thought of in very sort of narrow terms, just, daylight factors for rooms or making sure you get 10 liters per second per person for fresh air. And, the design of a building can really impact the long-term well-being of a person. And I think we're starting now and see quite a big change, integrating some of these ideas of how to improve long-term health and well-being. So that's a positive thing, but I think it's something that needs more, needs to be more.
Can I just add one more comment? Just add one more comment on that. What we tend to find over the last 10, 15 years is that it's not so much how much it costs, but how it makes you feel, how building actually makes you feel. That becomes increasingly more important.
One more thing.
Sure.
Tiny. No, it's just to say, like in terms of like a smaller scale projects, what I find really amazing is this sort of idea of us, like, trying sort of imagine sort of systems that are quite smart in terms of like the design. So something that you could say is very high tech design, but also giving the community or people, that will live in there, this sort of low tech fabrication opportunities that in the end, they will end up with something that is still very sort of not easy, but, like easier for them to build, but it's actually very smart from a sort of, like a high tech sort of perspective and design. I find that really amazing, and so wanted to just say congratulations for that.
Great, thank you very much. I just want to thank our speakers again in the traditional way, and I'll see you all back here at 11:30.
No, just hi, Anne. Hi, Franklin. Nice to see you in the AA. Even if you're that little small there in the corner, we miss you.
Yeah.
Thank you very much.
Great to see you.
So we start a second panel on carbon. We have three speakers. One of them, Pablo, is on Zoom, and then Kian and Tony are here. And yeah, I will just give the floor to Kian. Kian is a structural engineer. He's interested in reflecting in the built environment by means of looking at new technologies and processes for sustainable construction. And he's highly engaged in teaching here at the AA, so you broadly know him. And he will speak about the whole life of carbon design.
Okay, so hopefully you can see the slides and you can hear me. So I'm going to be talking about whole life carbon design, how you can design, think about all the carbon stages. And I have to say, this project was only possible thanks to all the hard work of the different people I got to work with. Zhang Harrod Davis, Worth Gardens, Shashank Jan, Tabitha Binding from TP UK, and Billy Adams and Freddie Wiltshire, as well as all the sponsors who are involved. I can't start any presentation without reminding everyone that it's not just carbon and it's not just biodiversity, it's everything. So that this comes from the IPCC report of 2018, which is the one that kind of lit the fire under everyone. And it reminds us that it's not about addressing one of those sustainable goals, it's about addressing them all within our design. But as part of that, carbon is an important one because those carbon emissions are directly linked to their climate impact. And so this is the method that we currently use for whole life carbon assessment. It's split into several different stages where we consider the products that we're using, then the method of construction, how we're using that building throughout its life, and the end of that life. And then there's our last section, which is kind of benefits and loads, additional things that don't really fit into those categories. And this sphere, this understanding of carbon design is completely continuing to evolve. So actually, even this diagram might be wrong in a couple of weeks. Whole life carbon assessment might be redefined to only be A to C. The other thing is that there's other modules being added to this as we speak to encompass aspects of carbon in our projects, which isn't included in this. For example, an A0, a B8, and a B9. But I want to talk to you about a project where I've been able to kind of think about these stages in practice. And again, because of limited time, I'm going to focus on the ones that I think are the most interesting. This is Woolworth Gardens. If you haven't had a chance to go there, it's beautiful. It's probably one of my favorite places to go to in London, and it looks like a jungle. And as part of its work in education of people and gardeners, they needed a space to teach during COVID. So we created this, which is the horticultural classroom at Woolworth Gardens. And we can talk about really good exchange rates to make sure that the air stays nice and open. You can't beat this one for being open-sided on all sides. And we were able to, in this very simple project, be able to incorporate lots of different things that we think is a way that we should be thinking about our projects, thinking through all of those different stages and being really smart about the way that we design. So one of the first ones is about the choice of material. Softwood timber, cross-laminated timber are obviously at the very bottom end in terms of their embodied carbon. So that's the kind of choice of material that's a good choice of material that we went with. Actually, again, talking about things changing, even though softwood timber and cross-laminated timber values are expected to change in the next couple of weeks as more research into these comes out. The other thing that we can start to think about is the foundations that we design with. A large amount of the carbon that we work with that's in our buildings are going to be in our foundations. So is there a way to kind of minimize that? And we were able to minimize actually the impact of that by using gravel-filled tire foundations. So this meant that we had no cement, that we were minimizing the depth because we didn't have to necessarily deal with the same frost issues. And we're using recycled materials as tires. And this whole thing could be removed and reused again in the future. There's also a desire that not everything has to be about carbon. Sometimes it's about being clever. So this on the left is an image from an existing building on the site, which was made by the female construction group Matrix when the site was originally started. And we kind of wanted to replicate that in design on the right, but its sandwich joints aren't necessarily the most efficient joint to use. So just as a reminder, when you have a beam, the most force, the bending moment is a measure of where the most force is, and the most force is for a beam would generally be in the middle. So if we worked for this project and we cut it up into how it's working, then we're going to end up with a bending moment that looks like this on that bottom beam. So we kind of get left with a choice. Do we add in much deeper sections to make that bottom section work, or can we be clever? And by adding in an extra row of foundations, we're able to keep the section sizes the same. So using similar sections throughout the project, and just adding in an extra row of foundations. We can also think about the transportation of our products to our site. Now, on the face of it, it looks like things like rammed earth and concrete it looks like concrete made more locally would have been better than our use of timber. But again, it's really important to remember where are our big hitters. And so the embodied carbon, A1 to A3, is actually a larger component than the A4, which is only about 4% of our whole life carbon. So using timber, although A4 might be slightly larger, A1 to A3 is much lower. The other thing is that this whole thing was built using hand tools, and so we could minimize the amount of machinery that we needed to use to build this. And the amount of cutting that was made in those sections was actually really tiny, so our waste from the project was reduced. The other thing that we need to start thinking about is that our projects don't finish, but they continue. They are a kind of state of being, and that they will change over their lifetimes. So a project that has a 60-year life might change ownership every 20 years. So that means it's going to change ownership 3 times. If it's a renting period, it might be every 2 years. And then major refurbishments for most projects happen at least every 30 years. So our projects are going to change, and be able to take that into account is really important. So the idea is that the project in the future is we're going to clad the project. Once we can safely do that, we're going to clad and enclose this project. So that means that we're going to end up with much larger forces on the roof as we put in deeper insulation, maybe a green roof or some glass on that roof. And that's not what those sections were designed for. So we can be a bit clever about that. And we've designed this in a way that actually it can be turned into a truss. And by turning it into a truss, we can use smaller sections now, and so reduce its whole life carbon design. There's other aspects. So we were looking in the future that we're going to be placing our roof lights in order to minimize the amount of artificial lighting that we're going to need for our spaces. And then we also need to think about what's going to happen to the end of our project at the end of its life. There are different strategies. We should have a strategy. And so we kind of thought about that a bit in this project, that The timber is made out of standard sections, which could be reused. It could also be dismantled and made into sections, split into different parts. This could become 2 smaller sheds. The sections have had their minimum amount of cuts, so actually the reuse of that timber in another project becomes much more viable. And actually, the other thing you might notice is that setting out of some of those sections that we did cut, so on the side, wasn't set out by any kind of architectural necessity. It was actually set out on basically where, if we cut a piece of timber, how long is that piece of timber, and that set out the spacing of our bays. So that's all I wanted to talk to you about, is that we should think about our projects from start to finish. And we can use the whole life carbon as a way to do that, and we can use the whole life carbon assessment as a way to count the carbon. Thank you very much.
Thank you. Okay, so we are gonna go with our second speaker, Pablo, who's online. Hi, Pablo.
Hello, how are you? Can you hear me?
Yes, I can hear you well. Just briefly, Pablo studied architecture in La Coruña and sustainable environmental design at the AEA. And he has been an environmental consultant at Chapman and Atelier 10 for the last 5 years. He will speak about design for manufacture and assembly today. Thank you, Pablo.
Hi, I'm Pablo Gugel. I'm the head of sustainability at Brighton Wood. The presentation is about platforms and design for manufacture and assembly. And this is a relevant topic nowadays because there's a new document that was released by the Infrastructure and Projects Authority in the UK. And this document is called Transforming Infrastructure Performance Roadmap to 2030. And the document talks about the inefficiency of the construction industry. We need to improve it compared to other industries. And they make a very specific reference to the adoption of platforms and the design and construction and the use of design for manufacture and assembly. This document is basically saying that within 2 years, all the public infrastructure projects will have to adopt platforms. It is quite possible that this expands into most of the public sector, and many developers in the private sector, they're interested about the subject already. So what is design for manufacture and assembly? Most architects nowadays, they have control of the design of the building, but they don't necessarily control the design of the manufacture of the products, which are part of the building. So DFMA, design for manufacture and assembly, is a methodology in which the architect designs the manufacture and the assembly of those products as well. So if you look at any construction site 50, 60 years ago and today, there are so many things which are still the same. And that's because the industry has not evolved at the same speed as other industries. If you look at the car industry, you can see the difference is huge. It would depend on human beings to do most of the work, and now everything is mechanized. So what the car industry is doing is designing their own factories, designing the manufacturing process, and designing the cars. We only design buildings. We don't design the manufacture process. The benefits of this full approach is that you have better control over the cost, obviously. The productivity is much better. But crucially for us, because we're interested in the environment, the embodied carbon gets reduced, the amount of water gets reduced, the amount of material and the amount of waste gets reduced. And it is a huge impact if you have control over the whole process. So the car industry, they have control over each individual component in a car, and we should have full control over each individual item within a building. This is the Forge, which is the case study that I would like to talk about today. So platforms is the other term I mentioned before. This is slightly more abstract and is a framework or infrastructure with a set of components that can deliver a product. And this is a term that was taken from the software industry. Just to give you an example, because the platforms approach can be applied to many of the other industries. In the transportation industry, a component is the shipping container. The platform is the freight infrastructure, and the service that they deliver is the transportation of a product. In the case of the iPhone, for example, iPhone is a platform that can hold many different components, which are the apps, which can be Uber, or it could be many other type of apps, and they deliver a service, which in this case is a taxi service. So what is platforms in the context of construction? It's about identifying commonalities, and those commonalities are usually related to the grid, the span and the height of the room. And the way we understand it is we have 3 tiers of platforms, platform 1, 2, and 3, that they can accommodate different types of buildings. So platforms 2, for example, could accommodate residential, office, healthcare, and schools, because they can be supplied within the same kind of grid and structural solution. And this is our solution for platforms that incorporates all the DFMA technology, and I will explain how it works in a second. So the Forge is the case study. It's a commercial building developed by Landsec in central London. This is an experimental building because what they requested is that we develop a platforms approach based on DFMA that they test in this building and they use in all the commercial buildings that they develop in the future. So it's a bit of a testing platform. And the environmental aspirations are really high. It will be the first commercial building in the UK to become net zero carbon, both embodied and in operation. It's a neighbours pioneer project, and it will be the first commercial in the UK, the commercial building in the UK, to be based on platforms and design for manufacturing assembly. So the only way to deliver a full DFMA project is to have a well-integrated BIM model that has the structures, the facade, the finishes, the MEP, absolutely everything to a lot of detail. And the approach to the structure is to optimize each single element, which is designed in a bespoke manner. And we have just 6 key components that can have different spans, and they are connected with just specifically designed brackets. So what we are using is a kit of parts of elements that they are designed with the maximum efficiency and accuracy. So in essence, we are not using strange materials. We're just talking about concrete. We're just talking, it's a steel deck with concrete and steel. The difference is that each single element is optimized to reduce the amount of material so that we are reducing the amount of carbon, and to be built much faster, reducing the program with less risks to the operators. And what is crucial is that it's built in a very simple manner, so that all you need is a bit of training to the operators to develop it. So we built this mock-up. So this is the platforms, the original platforms prototype that was put in practice later in the project. So one crucial aspect is that most or all of the steel elements, they are manufactured with robotics, and that brings the accuracy to 1 millimeter. If you think about most structural elements, they have an accuracy, a margin of error of 50 millimeters. Because you're more accurate, you're faster. And in terms of how you bring MEP items, facade items, that's making a much faster product, a more accurate product. And in the case of the facade, that's making the airtightness of the building much lower, which means that the operational and performance of the building is better. This is a video that shows how this is actually manufactured. So one thing that you'll notice is that everything is done by just 1, 2, or 3 people. The whole structure is built by just 1, 2, or 3 people with the support of a few machines. So we have the comfort beams. You can actually see the technology is quite simple, and all you need is a few people connecting a few screws here and there, and everything is color coded so that is easy to follow. In a way, it's an IKEA construction of a building. We're supported with a few bespoke solutions and robots, and everything is done underneath. Most of it is done from underneath to improve the efficiency, the speed, but also the security of the operators. The facade is made out of just 7 components, again, to speed up the process, and each of these components are just responding to the daylight and solar and energy performance of requirements of the building. The MEP components, they follow the same logic. In any given floor, you have just 7 modules for the fan coil units. So they come in kits, and they go to the on-site with a lorry in a number of trays. They are taken with a fork, and they are just put in a very quick manner. And because the accuracy of the building is so high, the construction speed is reducing substantially. And there's no waste, obviously, which is really important. This is how the building looks at the moment from underneath, is under construction. So what are the sustainability benefits? The adoption of DFMA, because we are making each component more efficient, it means that we have less materials. By having less materials, we're reducing the embodied carbon. we need fewer transport movements, and we have less waste. All of this converts into less carbon emissions. And also, we are making a building which is lighter, which means that the foundations are smaller again. And again, this converts into fewer embodied carbon emissions. If you look at the whole cycle of any typical building, typically carbon emissions, the highest part of carbon emissions is within A1 to A3, which is the product and the manufacturing, followed by the use, which is essentially the replacement of the building. Because we have control over A3, which is manufacturing, that means there's a huge opportunity to reduce embodied carbon. Also, there's an opportunity to reduce embodied carbon in transportation, because everything is fit and designed to fit within a lorry. And we have control over the amount of waste, which is A5, and also the amount of waste that's generated at the end of life, which is C1 to C4. So there's a much bigger opportunity to reduce embodied carbon by the adoption of DFMA. This is the exercise we did to quantify the benefits for the Forge. So in the chart, you see business as usual. So we created a baseline, and we compared the carbon emissions from the use of PDFMA combined with the lean design, and that brought us to a 19% carbon reduction, which we brought to 24 by the specification of concrete with GGBS, the high carbon recycling content in the steel. We didn't use any raised floor, drop ceiling, and all the raised floor is recycled. And the basement, because the building is lighter, is substantially simplified. Other benefits from this approach is that we reduce the tonnage of the building, of the steel, by 18%, the amount of concrete by 13%. We improve the construction productivity by 55%, the delivery time by 30%, and cost by 30%. All of this is a huge achievements, and they all have an impact in terms of, from an environmental point of view. So I think this summarizes the potential, and we keep on redeveloping and redesigning these DFMA and platforms so that we can apply to other buildings. Thank you.
Thank you, Pablo. That was great, super holistic. So we have Tony up for our next talk. Maybe we can have the presentation coming up. Tony studied architecture in Valencia and also in Barcelona, his master's, and he's based in London since 2010. And he recently founded Moy Architects. He will speak about the net zero carbon school today. So welcome, Tony. Let's see if we can get that presentation on.
So the project was to be built in Bevagna, which is a little town in the countryside of Italy, in Umbria. You can see in the map here. And our plot is right outside of the town center in a beautiful environment, all green, grown-up trees, beautiful mountains on the landscape. So only the site encouraged us to be as respectful as possible with the natural environment, with the project that we were to propose, and try not to destroy the site that we were given to build. So the main ideas that we wanted to develop in order to achieve a respectful building with environment that could be, by the end of its construction, a net zero carbon project was to build a project that could be in harmony with nature, that respected the land where it sits. And we needed to make sure that all our design decisions were driven towards the reduction of the carbon footprint of the design. And that meant for us get more with less, using the least amount of materials as possible, that these materials had to be obtained directly from nature and had to be obtained within a certain radius, say 50 kilometers, 100 kilometers, but obtained locally. And ideally that these materials had not been through heavy processes in the industry from nature to building. And use the trees as an element of design in the same way that we can use a brick or a piece of timber. So the first big decision is to occupy only 50% of the plot. We can see that's the whole site. So we left the bottom side, that it's the site on a slope. We decided to leave the bottom of the plot empty as a park. and use the landscape in our favor and concentrate the proposal within the rest of the 50%. And try to adapt a series of small buildings along the contour lines, so reducing the potential soil waste, and make sure that the orientations of the pavilions was the ideal to control the natural light and to maximize the solar energy for the PV panels that we were to install on the roofs. This is a little section showing how we were trying to excavate the least amount as possible. The idea is to keep all of the soil of the plot within the project. So the excavation is the land or the soil that we use to infill other parts of the site. And in case we cannot reuse all of it within the topography, the remainders will go to the local industry where we will produce rammed earth panels. That was our choice to clad these buildings. A series of solar studies to inform our decisions and have a stronger tool how to orientate these buildings. The classrooms are facing the northwest, that with little help of fins block the direct light into the buildings. And a small sketch showing that from the very beginning, these ideas had to be present in the project. So it's not an add-on at the later stages of the project. Thick walls enclosing the central space, open facades towards the landscape, little pavilions that are compact buildings as small as possible, so we reduce the amount of material that we're using, so we reduce the carbon footprint of the entire project. And because we are in Italy, this is the final plan, we can use the outdoor space to be part of the architectural project. So if we are building the smallest pavilions that we can, then the connections between those pavilions can happen on the outdoors, where we don't need to build a roof, we don't need to build the cladding, and therefore we are again trying to reduce the material that we're using, being more respectful with the environment and reducing the carbon footprint. These are a series of views of how all these ideas can come to reality. The constant presence of trees, which is as important for us as the rammed earth of the walls and as important as the stone used for the pavement. Another view of the center of the project, using architectural tools to solve those changes in levels, proposing outdoor spaces to learn for the students. And we can see here that we have constant references to the landscape in the background, because it's not only about achieving a net zero carbon school, it's about achieving a school that makes the students feel they are in nature. So that attitude towards the environment is already nurtured from the very beginning. Another image of the patio. And this would be, sorry, like a first sketch of a constructional section. So to keep the logic within the design, we have to make the materials work at different levels at the same time. So the timber that we use to build the roof is already the finish. The beams that hold that roof create the character of the space. The timber floorboards that are the preform for the concrete that contains the underfloor heating are the soffit. So everything is working at 2 or 3 levels at the same time. We plant a green roof above the offices or above some classes that not only protects the space below, but it also helps capturing the CO2 of the atmosphere. The trees that we are incorporating as part of construction elements into the design are also working hard, exchanging CO2 for O2 in the environment, and making sure that the above ground of the building is as light as possible. No? So we use the timber, very thin sections. We proposed this 6 by 6 meters grid that recent studies, as Johannes was saying, have proved that it's like the sweet spot to make the structure work efficiently in terms of CO2, embodied CO2. And it also works well to design classrooms for 15 to 20 students. And just to finish, where we can't reach with all of these passive strategies, we have the technology of the 21st century that engineers that are like Xavier that helped us develop this project can bring into these designs. The air intake from the outdoors, this is the winter case. We intake cold air like by the action of the soil, which is constantly at 15 degrees in this part of Italy, helps it warm up a little bit. That helps the air handling units work less harder. And that warmish air is then used to warm up the classes. The sun comes into the school, heating up the floor, and all that together with the energy of the people that's inside the building is already working to heat those spaces up. Then that heat is recovered and contained within the mechanical systems to be reused in this same pavilion or other pavilions within the campus. And that energy stored can be reused at later stages. And just to finish the summer section, the cantilevers help protecting the facades. The warm air taken from the outdoors is now cooled down through the action of the soil, taken to the air handling unit. That also needs to work more, that makes it work more efficiently and use less energy, therefore we're reducing the emissions of carbon during the life of the building. And the section with its inclined roof, that by its own geometry is helping us take the hot air to the outside. And that's it. Thank you.
Well, fantastic. Thank you, Tony. So we'll start with the discussion. Pablo, if you want to turn up your camera as well. Thank you. We have John and Anne-Sophie of Territorial Agency. They just, hello, hi. And we have, wait, because I have a couple of people. I don't know if Diego's there. Okay.
Hi, everyone.
Hi, sorry, I was not seeing you. And then Toby McLean is here in the room. Hi, Toby. So I will actually give the floor to them for the first comments. Ben, if you don't mind, can we just unshare the screen and then we can see everyone's faces? But yes, please, first comments, go ahead.
Hello, everyone. It's fantastic to see that the ETS is called ETS, and this is really a mark of how far the Architectural Association is moving and has decided to embark in addressing the major challenge that we are all facing with climate change. I am going to give you a little bit of insight in the way we think, and we've been doing work at the school in Diploma 4 around the notion of carbon. And we start, of course, with the major marker of contemporary life. The latest reading of CO2 concentration in the atmosphere done 2 days ago on Mount Mauna Loa in Hawaii is 419 parts per million, actually 419.05 parts per million. It is now winter in the Northern Hemisphere, and so the emissions of CO2 in the Northern Hemisphere are a little bit lower than they used to be last summer. But nevertheless, this winter is higher than last winter, and of the winter before. And the problem of why we're dealing with carbon is really the fact that we have impinged on the self-regulating system of the Earth that is given by life. The Earth is irradiated, reflects back through clouds and ice and snow, the radiation of the Earth, and life maintains levels of carbon in the atmosphere and other greenhouse gases in the atmosphere at levels that make the Earth inhabitable. Over the last 150 years, with a rapid acceleration. Humans have started modifying that. And we have currently 10 billion tons of carbon emitted into the atmosphere every year, on top of the self-regulating systems of the planet. So the 10 billion tons every year are produced, of course, by burning fossil fuels, by land use change, and of course, by producing concrete. We need to reduce those 10 billion tons a year to zero by 2050. We can reduce them by half by maybe 2030 if we are all good boys and girls and we manage to do and implement your projects, the fantastic work that we've seen today. And we need to be able to do that quicker. But you saw the figures are fantastic, but they're limited. We can improve here and there, make here and there a little bit more efficient the conditions. What is clear is that we need to reduce drastically the burning of fossil. It's not enough to make the reduction somehow in the production of cement or the reduction in the way in which we operate, for instance, even through renewable energies. We need to reduce drastically the burning of fossils. Well, it's not enough actually to reduce drastically because the debris that we've left in the process of rapid urbanization and construction of what we call the technosphere is so vast and the magnitude so vast that we need to start thinking at different meter, at a different level of coherence. So the current technosphere, which is made up of cities and infrastructures and plantations and, for instance, to create the wood from wood timber and the food that we eat, the energy fluxes that we use and the information flux, it is around 30 trillion tons. And it consumes around 600 exajoules a year, which is of a magnitude similar to net primary production. That is the beginning of the food chain of life on this planet that is producing through photosynthesis organic compounds that are then eaten by. So the technosphere from within seems a condition that is produced by design, and that we are endeavoring all to improve the design. And I think that we also, in this fantastic set of intelligence that was put in front of us in this session, how we can do that. But what is interesting of understanding its magnitude is that it's now a quasi-autonomous, self-organizing paradigm of the Earth. It means that we are a major component of it, but we're not the driver of it. We are not the major intelligence shaping it. We are, on the contrary, shaped by the technology. We are becoming more and more entrapped in an inversion of agency. It is us working for the technosphere rather than the technosphere working for us, rather than technology being a tool for us. And this is a really difficult situation, which I think encounters a different level of the notion of carbon. And it's the last thing I think we want to say, and that is to think making architecture and doing architecture at a moment of such upheavals and what we would call climate chaos, with so clear tasks ahead of us, implies reinventing what it means to think technology. Because it's obvious that we cannot solve the problem of too much technology, this 30 trillion tons sort of metabolizing carbon fossil and emitting more and more debris in the form of infrastructure and technology. We cannot think of dealing with that by adding more technology. What we need to do, on the contrary, is trying to understand the overall necessity to augment the capacity of recycling of the technosphere. Recycling of the technosphere requires more energy. Every system we know very well, in order to start recycling, requires more energy. Where are we going to get that energy from? The biosphere. From photosynthesis, from the fixing and oxidizing the carbon in the atmosphere through photosynthesis. Just as an example, the current levels of steel use per capita in the United States is very similar to what it used to be in 1980. It's around 11 or 12 tons per capita every year. So it has plateaued, and we can imagine that the United States is a major industrial system, and many other countries will soon reach that, and we soon having 8 billion people. Now, the reserves of the United States have in the United States are around 4.6 petagrams or billion tons. The use is 3.2 billion tons, so they're equivalent. Now, what is interesting is that the grade of the steel, of iron, that we can produce by extracting the new steel is almost half of the grade of the old steel that is in the cities, that is in the structures of railways, it's in the structure of skyscrapers and low rises in the concrete. So if we would start recycling and mining.
We are losing John.
I think he's still working on the stream though.
John, we're breaking up. Yeah, I think it's them. So maybe well, it was he was in the middle of making the argument about steel, but maybe we can try to pick up from these comments he was elaborating on. I was thinking of you, Kian, but also maybe Pablo, in terms of speaking about this whole cycle that John was mentioning. Actually, he was opening up, I think, to a bigger understanding of the cycle. So I don't know if you want to elaborate on that.
Sure. Yeah. I think there were some really good points from John and Anne on the need to understand, but it's at the same time that it's an emergency. So we can't just take the kind of time to wait until we understand everything. We have to act at the same time that we're learning. It's not an ideal situation, but I think that's the one that we're in. John was jumping towards that point at the end, that some of the greatest impacts that we can have is actually by not creating new. And so that jumps back to the idea of reuse and reusing elements, and so the circular economy. And then like the scale of this problem, they were kind of talking about is massive. And I'm going to kind of like steal a quote from the director of sustainability at Arup, where she said that the kind of addressing this issue kind of requires the same kind of bravery that the space race had. That they didn't think they could land on the moon. They said, we're going to land on the moon. And by investing in that, they were able to do that. And that's the kind of bravery and kind of like attitude that we have to take. And the last one is that I'm kind of excited about this. Like, no one has had to deal with a climate emergency before. So none of the forms of architecture that we've seen before are what we're going to see for the next 30 years. So this will have a new form of architecture. And I'm really curious to see what that looks like, whether or not you can see the fact that it's low carbon, everything's marked to say how you reuse it, and has extra holes so that when an element is taken down, it can be reused straight away somewhere else. So yeah.
Yeah, sorry, John and Sophie, you broke up, and then we picked up with Kian, who started.
It's great to continue with the discussion. We are here.
Yeah, I think Kian's introducing the question of speed was spoken about in the first panel as well. I was wondering if Pablo has something to say about this point, and maybe then see if Diego wants to enter the conversation.
I completely agree with the point of circular economy. There will be a few talks in the afternoon about it, but I think making buildings that can be reused and recycled and refurbished as many times as possible, it's essential. We need to make use of the existing materials in the building as a resource and try not to use new materials where possible. that would be, to me, the first thing to do. The second thing to do is to make buildings more efficient in terms of, well, we've been designing buildings to be more efficient from an operational point of view, but also from an embodied carbon point of view. And the easiest way to do is to use less material. So for that, we need to make structures and facades and buildings that have less material. So the structures, they need to be optimized to its maximum possibility. And the construction systems, they need to address this, which is why I was pointing out in the direction of the FMA. And I think that's really important. I think trying to be efficient. The other thing that is really crucial, I think is probably the easiest way to make the embodied carbon of a building to get reduced, is to make buildings smaller. We can see lots of public buildings, particularly, which are huge. I mean, think about airports. I mean, or any public kind of space. They have huge spaces that sometimes they are not used for very long periods of times, with huge volumes that you need to heat up and cool down, with lots of materials that you don't need. So the best thing to do is in designing buildings to fit the right space that the right use. With that, you can trim out 10-20% of the embodied carbon of any building. So sometimes it's a matter of being efficient and logical.
Great. Diego, Toby, you're here in the room, so we are actually postponing you more than the screen people if you want to.
Okay, yeah. The emergency, as Kieran said, is now, and probably will be for some time from now. Designing buildings for reuse is great, and it's be really helpful when those buildings need to be reused, but that's not now. For me, it's much more important that the emissions we know we're going to emit now, the certain emissions which are contemporary, are addressed in a radical way. So I would say, exactly the architect's job to not design buildings unless there's some justification for that. And what that threshold is might be an interesting question people can ask themselves. By what threshold? How do you decide when that threshold is met, when you're going to need to design a new building? And it might be by not designing the building, the carbon emissions will be higher than if you do design a building. But you still then need to consider the timing of those emissions and certainty of top emissions, which are now the upfront A1, A3, or A0 emissions, which might appear, compared to the possible emissions in the future. So the possible emissions at end of life, which hopefully won't be in 60 years, but will be in 100 plus, 200 years time, because if you don't knock a building down, you don't have the end of life emissions. And the operational emissions, which are a big issue, but as the grid is decarbonised over the next decades, will be reduced as well. So the really key thing for me is the emissions, the 420 parts per million currently in the atmosphere, and really trying to bring that down as quickly as possible. And that's for me about the emissions that happen right now.
Right. Kian, I don't know. I mean, I'm pointing to you because you've made a lot of arguments about how do you measure actually, and I think you are also like investigating that, no? Like the gaps in measuring and how to measure. And you were telling me the other day about how there are tricks on this measuring as well, and so I think maybe you can.
Okay, yeah, no, I was talking about when people start to measure emissions. Sometimes they're not using standard things like CO2e rather than CO2, so they can hide. So they can say that they're zero carbon, but they should be zero carbon equivalent, which would be covers all the kind of gases that affect greenhouse. So there are tricks to hiding it. I think Toby's point is really, really interesting. I was thinking like while he was talking, I was like, oh, what would the design situation lead to be like that, where regulations are so tight that that you have to kind of prove that building needs to be adapted now, or relatively urgently, in order to kind of get started on it. And then we have, as designers, we have more time to actually look at it, take the time, work out how we're going to change it, and then make those interventions thoughtfully as part of a regulated process, rather than this kind of urgent, get approval as quick as possible. And I can imagine that being really, although it would be, as Toby was saying, it's build less, but actually it could be really rewarding to be able to spend more time to do it in more detail, to kind of put the care that we all want to put into our work, and to know that and not be kind of guessing as much, because you've been able to take the time to know that what you're doing is the correct intervention. I kind of like that.
Pablo, I think Tony was telling me you have developed some tool about assessing this problem, no, of rebuilding or holding the new design, the new.
Oh well, I think the problem is I was actually involved in a research.
It was actually a question for Diego from WSP.
All right.
Sorry.
Wait, I mean, yeah. Let Pablo go ahead, Pablo.
Sorry, Pablo, go ahead.
Okay, I'll be quick. I was just saying that I've been involved into a quick research about the benefits of reuse. And I think it ties up with this idea of the emergency. If you really reuse a building today, that's a lot of carbon that you're not using today. If you develop a new construction today, there's a peak of carbon emissions for the materials today. And even though a new building is more efficient from an operational point of view than a reused building, because the efficiency of the facade and etc. will be less, the grids will be decarbonized in hopefully 10 to 15 years. So the advantage of new buildings from an operational point of view compared to refurbished buildings will be diminished. And what is important is that we address carbon emissions today. That's why reusing and refurbishing buildings is so important.
Great. Diego, yeah, sorry that we overlapped.
No, that's fine. I excuse me, I couldn't agree more with all the points. Maybe I just wanted to share the journey I've been through the last 18 months since I took the role of net zero lead for WSP, and it's been a journey that has helped me see how the industry has been responding to this. And as an anecdote, I mean, Tony and I worked on a project in the city, and we calculated that 1% of the emissions of that building were equivalent to 100 years of my life. And that's when I realized that my previous ambition as a structural engineer and that motivation of, whoa, I built that, it suddenly became, whoa, I built that. And what can I do differently? So we started this journey, and following the principles which we've shared, everyone shared in these presentations, using less, absolutely. But there's much more than that, because the influence that we have as designers is important, but we need to focus that influence on the key market drivers. So although we have been working on decarbonizing all the processes that we do, all the designs that we create, we have seen an increase in the amount of office space that is being procured, that's being tendered. And I am currently working on buildings which are twice the height of the ones that I was working 5 or 10 years ago. So how is that sustainable? We're focusing sometimes on LETI targets, which focus on embodied carbon per square meter. And I can happily say that we're achieving LETI 2030 in some projects already now. But if that project is 10 times bigger, then what's the point? So how do we influence those market drivers, the ones that require us to build less? How do we as designers take all of these initiatives, and I'm sorry, I'm not answering the question, I'm asking more. How do we as designers have all these incredible initiatives, fantastic ideas? How do we influence those making the decisions so that we can actually use less, so we can actually build less, build more efficiently? How do we, a simple example, post-tension slabs, everyone wants to use less cement, everyone wants to increase more the amount of GGBS, etc. Even if it's not as sustainable, that's a different conversation. But if the driver is cost and program, they will not do it, because if they are competing against cost and program, they have no initiative and no motivation to drive carbon emissions down. So how do we address those key market drivers? I think is incredibly important. And the conversation started about around steel earlier. And there is an initiative, for example, called Steel Zero. And it is doing that. It is sending a signal to the industry that there is more demand for lower carbon steel, so that the rest of the steel industry has a motivation, a financial motivation to decarbonize. Because unfortunately, what I've seen And I actually saw that yesterday in a meeting with a client that wants to build a 100-story building outside of, it's not in the UK. When we presented the principles of sustainability and low carbon emissions, they were not interested because in their market, it wasn't something that would sell as much as it sells now in the UK. So as a designer, I feel powerless of what I can do. How can I influence that client that is not interested, even though the climate emergency is now and we need to save emissions now? So I guess I'm agreeing with everyone that there's a lot that we can do and we need to do, but I'm also asking the question, how do we influence those that can make those decisions?
Can I intervene?
Who do you want to give that
to? No, I mean, to tell you, yeah, I think I know. There's people wondering about this. Oh, sorry, because I have this delay here. No, Diego, I mean, I don't know. I think we were all like silent and thinking now because there are these kind of two scales. And yeah, John, please go on.
I don't know if was it Kieran who wanted to intervene first, but I have a point about how we can operate on the demand rather than only on the supply of the design. And I really think that this is the role of architecture. It is the role of architecture and what we call design, even though I particularly dislike the notion of design. It has become too much. Architecture inspires and keeps focus on societies in their goal. It's what shapes the identity of a polity. If you are from Siena, you know that the architecture defines you. If you are from London, the compressed impression of the globe coming in one space is what defines you. It's what shapes the long-term horizon of a society. So I think that architecture needs to be far more emphatic about its capacity of hospitality. And we need to be very more clear about how we can drive the process. It's not how do we define now our agency so that we can talk to people who have agency. It's really understanding that a group of people concocting plans have incredible anthropological power. People look up at architects and planners. They are really moments of enabling capacities. The point is we need to be far more transparent in this. We need to be far more eloquent, articulate larger audiences and public so that they understand that architecture is probably one of the way through, not part of the problem. And at the moment, we've been very much focusing on the meter, also in the discussion of a building at a time. I think actually that we might have to change the meter of reference. We need to make people understand the magnitude in which we are. But architecture is the way in which we influence. And we have some projects that do that in other domains, and I would like to share them maybe one day with you, Diego.
I mean, it's a huge challenge in a way. You know, the curve that we're all discussing and talking about today is the hockey stick curve, and we will at some moment need to go hockey stick down and very quick, right? And totally, it needs to come from the place of architecture. But the amazing thing in this discussion is that in the last 30 years, we have developed so enormously quickly our cities and the rapid transformation of our metropolitan areas. And if we did that so well in the last 30 years, we will be able to do it equally well in the coming 30 years if we just do it.
Absolutely.
Tony, I'm thinking maybe because this thing of architecture having to be more emphatic and communicate, no, like as John and Sophie were saying, maybe you can speak up a little bit about that, no? Because you were approaching it on that side of how to make architecture kind of speak for the challenge.
I mean, we as architects, we can. I'm a little bit on the side of Diego because I see myself one more player in the entire market, and when I I can promote values, and I can promote an attitude, and I can promote a certain way of designing things and using the technology available in a certain way. But I need someone to support the work that we as designers do, and that comes from the clients, the first and foremost, which are the people that are investing in these projects. For example, in the project that I just showed, if you saw the winning entry, you'd clearly understand that these people were not interested at all in preserving the environment or in an environmentally friendly solution. The project that won occupied the entire site. It was a massive building with obviously great amounts of space to heat up and cool down. So I don't know. I think that for the next generations to come, there's a role of academy in nurturing this attitude within the younger people. But that if we are in an emergency, as Kian was saying, it's like, how do we make all these developers and politicians understand the urgency of the situation? And maybe we can organize public debates and get the voice out there and be public about this. But we need a little bit of collaboration from administrations, from House of Commons here in the UK, or the government in the European Union, or the big players in the real estate market in London, New York, or the entire world, or wherever it is that something is being built. But it's a collective effort, and it's also an industry effort, because all these people that are producing the materials that we are buying to assemble our buildings, they have to adapt their processes. So their carbon footprint is also diminished. So it's I think it's a collective effort of the entire society in essence.
I'm kind of like, I'm with you, but I'm also, I also think that most change has to start like within. And I think that often we kind of like, one of the political arguments that comes is that we can't regulate this thing because the industry's not ready for it, and the industry's not ready for it because there's no regulation. And so I think it becomes this back and forth game. And you can also see it as a cycle, like we're not designing this because there's no supply, and supply isn't providing it because clients aren't asking for it. And it goes in this little loop. And I think that the only person in that kind of loop, it's not about where it's not necessarily about money directly, is designers, and it's the knowledge. And so if the whole entire industry was completely knowledgeable about this and was able to speak about it eloquently and knew how to integrate it into design, then I think that would force regulation to change, and it would force then clients to change and everything else. So I agree, everything needs to change. But I think that if we as designers chose to really up the level, then it would everything, every other part would come with it.
Can I maybe add something more positive then in that case? Because things are changing, and it's amazing how quickly they are. And the conversation in London 12 months ago barely mentioned the word carbon. Now I have clients asking us to retrofit their buildings they just finished because they're struggling to let them. We have in the office market, we have all of the current projects being developed. They must meet LETI 2030 because otherwise they will not be able to sell them. And now we have big residential clients as well that are starting to think about keeping some of those assets in the long term. So they're built to rent. So they're also thinking about what is the consumer going to choose to buy in the future. Just like we choose to eat less meat, people in the future will choose to buy flats that comply or meet certain requirements. So they are also looking at that. We have a large development in the southeast of London. It's redeveloping a shopping center with 6 towers and LETI 2030 targets throughout, reusing at least 50% of every existing structure. And things are happening, and finance, there's $130 trillion, isn't it, that we learned from COP26 available for sustainability. Things are happening. It's quite positive. It's happening at different paces in different parts of the world, but I absolutely agree. It has to start somewhere, and designers have this big responsibility to say. And if I can share an anecdote, something happened to us, to me 6 months ago, that in a project, the initial proposal was to demolish a 20-story tower. And I said, I cannot speak for my company yet, but personally, I don't want to be associated with a demolition of a 20-story tower. And I don't think anyone in this room wants to. And I think that helped the client to see what the future market would say about that project. And eventually it was also cheaper to use it, reuse it. But eventually that option was eliminated from the proposals. So I completely agree with Kieran. We have that role to play, and it starts with us.
Diego, I didn't mean to be negative. I was like really excited about it because it like as someone teaches at university, I'm like, more teaching for me. But the one that they're like, but coming back to your point, like the Leti targets. Leti was an organization founded by people giving up their time to do that. ACAN's campaign to get the embodied carbon regulated. Again, that's people giving up their time to push that through, and it's going to have its second reading, I think, next week.
Yeah.
So it is like people kind of getting involved and like doing it, and that's going to make the real change for this.
Javier.
Sorry to barge in here, but I'd like to continue two things that John and Anne-Sophie started, right? And the first one is a bit of a story, and the second one is a bit of a joke. You know how much I like jokes. The first one is that there is an element from what John is saying there, that we have to understand that we are Pied Pipers of Hamlin in a way. And so if we actually make our work attractive, if it's beautiful, people will follow. So I think that architects and designers have got to realize this as well. So it starts from within, as Kieran has said. But I think it's very important to highlight in our own minds, personally, individually, so that anything that we do, we do it with a conviction that we can change the tide, that we can contribute, however small it is, in the hope that perhaps those who are involved in larger things can happen. And I think that's what John was saying, that architects can do it, is what leads me to the second thing, which is it's a bit of a joke in the sense that Kian has quoted that person in Arab saying that, well, we need that, the enthusiasm and the vision of going to the moon, right? And how they made it. So I think it's fine, okay. I know what she's actually trying to say. And I'm going to break a rule, my own rule. I hate skitty blighters who, clever fellows. You say something and immediately they say something funny and this kills the conversation. But you know the joke, don't you? How many architects need to change the bulb, right? And then, the joke is that he says, does it have to be a bulb? And this is the thing, we are trained to think that way. Everybody will say, well, 3 for this, ha, funny, 11 for that, 1,000 people. We go and say, do we need to change the bulb? That's to say, we are trained to do precisely what we're actually doing.
Right, I think, I don't know, John and Sophie, you had the mic. Yeah.
I like the joke, Javier. It's always a good reminder of the attitude of architecture. Interesting parallel that an urgent issue and how difficult it is to tackle. Every day in the world, around 1,000 people are killed in a traffic accident. And you know very well that the car industry has engaged in transforming cars into sensing devices that slow down and detect dangers, and they talk live with hubs of telecommunication, with Transport for London, with buses and taxis and alert. And still, the mayors follow that goal of reducing the number of people killed on the street every day. There's campaigns by the mayor of London, by the mayor of Paris, by the mayor of Sao Paulo. Everywhere that you go, there will be traffic and warnings, watch out. And yet the number stays there. It's higher than overall the number of people that have died from COVID. The interesting thing of this is that we have thrown at the problem all kinds of intelligence, technological intelligence, political intelligence, communication, campaigns, the best campaign. I think this is the moment, exactly like for carbon, to understand that we need culture. We don't need only communication, market, technology. We need a cultural change. We need to rethink what the streets are. We need to rethink what a city is. We need to rethink what a building does and how it is. We need new designs. And again, culture and engaging architecture as major part of culture is key in that. So there are untreatable problems, and culture is usually the way we find coalitions to move forward in them. And I think that that is what we can learn from architecture. It's a cultural exercise. It's a civilization exercise.
Yeah, I mean, if I might just add something in here, because in a way I've been thinking, what does it mean for the discipline to embrace these strategies also, no? Like with what Pablo was showing, there is a whole different tectonics at stake. There is a whole different way to build, like even how constructive systems are thought of because of the structure and substructure footprint, etc. No, so in a way, as a cultural practice, as architecture as cultural practice, that I think, and I agree deeply with what John, you're saying, which is from there that we have influence, no, like an influence that is kind of possible to magmatically kind of take over an understanding that is broader than particular cases even, and have a long impact. And I was wondering about, and maybe this is a question for Pablo, about the new sort of standardization that is coming up with this. You've been in the first panel also talking about measures, and you've been talking about small buildings and how that impacts the result of the measurements. And I'm thinking, what are we in front of? Because we've spoken about industry about being aware, but also what is that we need to be produced. And I don't know, Pablo, if there is something there, that there is a certain friction beyond the fact that the model works perfectly well and it's super efficient, but what are the frictions in terms of what we standardize and what does it mean for the sort of new tectonics for architecture?
I think if you're talking about how we measure things and how we standardize our understanding of buildings, how we measure the success, I think there's a constant revision of metrics and targets, and LETI is an example. I mean, they've been pushing hard and hard. And in fact, there's been an interesting alignment between the targets from LETI and RIBA because they were misaligned. But we need to keep on pushing. And I think one thing that Diego mentioned is the problem of height. So the metric that we use at the moment is carbon emissions by square meter, or carbon emissions. What if we measure carbon emissions by cubic meter? That will all of a sudden make a lot of pressure, put a lot of pressure in the height and the volume of buildings, which is really important. We need to build less. That would be an efficient thing to do. But also, and we'll briefly touch on this in the afternoon when we talk about circular economy, but there are missing metrics about circular economy. We need to be able to quantify, we need to be able to standardize, and we need to be able to push. And I share the same optimism from Diego that there's been a huge change already, and we need to keep on pushing.
Oh, yeah.
I think in terms of how we measure carbon,
What's your face?
Yeah, in terms of how we measure carbon, the only really definite way of doing it that we can be sure that will minimize our carbon impact on the environment is to measure our carbon against the carbon budget we have left. So some scientists would say we have so many megatons of carbon we can emit in the next 100 years if we want to keep temperature rises below a certain point. And if we share that out amongst the countries in some kind of equitable way, the UK, for example, then has a number of tons of carbon they can emit in the next 100 years. So we have to divvy that up amongst all the carbon emitters. And the number of buildings we build and the carbons they emit cannot exceed its fair share. So we have to relate carbon emissions to actually some kind of target for limiting overall carbon emissions, not simply per building or in any format, per square meter, per cubic meter, absolute terms, but to make sure that we are serious about staying within that carbon budget.
There's another person. Wait, Janice.
Next time.
Just one note on Toby's last comment. This is exactly where the likes of Leti are coming from. They're looking at Paris Proof Agreement and say, how can we work that backwards? Truth is that it is really difficult to do it with current practices. And therefore, we can only push the situation as designers towards inventing new ways, new materials, rethinking as to whether we need to be changing the bulb in the first place or not, linking back to Javier's point. That's what I want to mention.
We need to wrap up. We have 2 minutes. So if anyone wants to add any points or make any last revelations.
I've got one thing I'd like to say is that I know that, so I presented about carbon measurement. And I still think it's really important. But I think it's really important that we have other metrics, that we do have other metrics. And so I'd like to see more in the future, more water footprints and ecology footprints. And I think those would then also push things that are on the margin of being acceptable well out of the water. So that's what I would like to see more of, but I'm excited.
Great. Tony?
I'm just committed to this case. And again, let me say that my efforts as a designer will be in trying to get a solution for all these problems.
Anyone on the Zoom, Toby, or anyone in the room?
I think that the commitment should be from absolutely everyone, and it should be on absolute terms. It's total carbon emissions, not emissions per square meter. I couldn't agree more with that. The carbon budget, it should be a carbon limit. It should be assigned, but that's another conversation. And make a commitment to reduce your emissions as an absolute value. And yeah, it's such an exciting time to be an engineer, an architect, a designer. We can change, we can make it happen.
Great. If anyone has a more cheerful note than this one.
Just a quick one to finish.
Yes.
In our experience, for instance, in our experience I'll put just Eden North because we're talking about that today, but when it came to the point that Brian was asking us for the LCA, for instance, we were like, okay, so how do we do this? Like, there's no baselines. Like, we had a framework that was set up by the Eden team and 3Adapt as well. But then when it came to metrics, as you guys were saying, it was very interesting to hear. We didn't have any baselines to start. And then, so for instance, all the words that Pablo was explaining in terms of how you measure like DFMA, how you do that. It really works when you have traditional buildings. However, as soon as you have a complex geometry, it's just not easy anymore, right? So, like when you start measuring all these things, it just gets really tricky, and it really cost me a headache because, we were like, okay, how are we going to do this now? We have no baseline, we have no traditional building at all, have no single piece is kind of like making sense. So you rationalize geometries as much as you can. However, it comes to a point that if you don't have the baselines, you don't have the metrics, and you have such a weird sort of geometry, then it's really hard to tackle. But even though, positive side, like Diego, I mean, I guess it's like, that it's even a better challenge to take, and we kind of kept pushing, and, I'm pretty sure we're going to get there at some point with technology and where things sort of roll on a little bit more than it is at the moment. So just wanted to share that.
No, fantastic. Thank you. Well, yeah, I think it was great. It was a great discussion. It was like an hour discussion, and so maybe we are ready for lunch. And thank you, everyone, for being here.
So the session after lunch, always a good one, is on circularity. And we have 3 speakers followed by the respondents, similar to the earlier format. I thought I would start this session by using 2 quotes from the architect, engineer, and philosopher Buckminster Fuller. Firstly, one that encapsulates this issue we're about to discuss, that we've already extracted all the resources we need for all members of the human race to live a high quality life. And secondly, he said, there is no energy crisis, there is no food crisis or environmental crisis. There is only a crisis of ignorance. So I'm going to introduce our first speaker, Tom Raymond. He's an architect and director arboreal architecture, a practice that innovates ecological design principles in both the technical performance and sensed experience of human habitats. He has worked around the world, as well as been teaching here in first, fourth and fifth years. So Tom, over to you.
Thanks, David. I think we live in extraordinary times today. I mean, who would have thought that people would be taking to the M25 last year, blocking the roads and risking arrest under the banner of something as seemingly mundane as insulation? And who are they addressing their claim of insulate Britain to? Well, I think they're probably talking to us, you know, as architects and other building professionals. We are now, I think, well aware of the disproportionate responsibility and potential for our work to impact on global emissions. And as we make personal choices about how we live and think about our own carbon footprints, of course, we must be crucially aware of how much bigger our professional impacts can be. I think in the projects that I'm working on at the moment, it's about 20 times more significant than my personal footprint, but it could very well be that depending on you and the kind of projects you're involved with, it might be 100 times more significant than your own individual actions. So I'm going to make two arguments in this short talk. One is that if we care at all about the emissions from operating our buildings, then we can't ignore retrofit. And likewise, if we care about emissions from construction and building materials and what it takes to make them, we can't ignore the opportunities of reuse. There are 29 million existing homes in the UK at the moment. So far, despite many conversations, we seem to be building them only at about 200,000 a year. So I would strongly suspect that by the time we get to the end of this decade, we're very likely to have only 8% of the homes as new buildings, whereas 92% of them exist already today, like the one we are using right now, all of these existing buildings. And yet I love to design new buildings, to draw them, to take photographs of them, put them in magazines, and hopefully collect a few awards for them. I think we're looking in the wrong direction. What about if we want to solve this problem? We need to be looking at reuse and retrofit. So I think that's the case for retrofit. I think there are strong arguments for reuse as well. As we've seen in earlier talks in this today, what does it take to make some of the products that we use in our buildings? It's astonishing numbers. And I think we're uniquely, sometimes even deliberately disconnected from the origins of the things that we use, whether it's buildings or our clothes or food. We don't know where these things come from, and many manufacturers don't want us to know. And perhaps that's because, in the case of steel or cement, the emissions associated with those are so enormous. Not just emissions, but of course impact on the landscape, on soil, water, natural systems, and so on from all of this extraction. And from the point of view of waste at the end of life of these materials, the ones that we're throwing away so readily, it's so vastly different from what we, as individuals from our households, something like 60% of waste coming from the construction industry. We're deeply implicated in these problems. And fourthly, the last kind of point about reuse is that we also have emissions, about 2.4% of emissions from the UK coming from the waste itself. So we're going to talk about a project of mine in East London, just one home in the 3.6 million homes in London. Here on the north side of Victoria Park. doesn't look like a lot of homes might in London. In fact, that's, as you can probably guess, it was a school. And it's actually a school that has existed in 3 different places since the late 19th century. It's moved along and across the road. And I think that's an important clue that we also need much longer term thinking in the way we approach design, to think about where things came from, where they're ending up in our lifetimes and beyond our lifetime. And perhaps this example shows how truly dynamic the city is when we have such a long-term perspective. So it was built as a school in 1910. It served as a primary school for 92 years until it moved across the road. And then it was converted into flats. And in 2016, we were approached by the owner to renovate and retrofit this southeast side. So with the approach that I've just described in mind, we were really came to this building valuing its bricks, its materials for their usefulness, their embodied carbon, their history. It started off as a small kitchen separating an open plan living and dining area, a door to the south to the garden, and no windows on that east wall. So our transformation was to open up 2 new windows in the east wall, open it up to the garden, a new wall in between the garden and the neighbor, and perhaps most importantly, a new lining around the whole interior of the flat that improved its thermal performance, reduced its reliance on fossil fuel powered heating through insulation and airtightness. We wanted to keep as much of the material that we possibly could on the site to find creative ways of reusing it, or just any way really of not throwing it away. We took those existing windows, turned them into a partition between the bedroom to let some borrowed light into the otherwise dark stairwell. We took up the flooring and reprocessed it on site. Not the best quality timber flooring, really. There's always the risks and opportunities of discovering what you might find as you take apart a building. But we reprocessed it on site. We developed a module, a small, medium, and large component that would allow us to get the most from the somewhat random lengths of timber that were available. And we turned it into a wall paneling system on top of an insulating material there, resulting in this cladding where we could vary the spacing between the timber modules so that we had slightly different acoustic properties or a more durable surface where it was needed lower down. And we wanted to express the layering, the fact that we had an existing building and then these new layers that were added one on top of the other, including details like the cornice at the top, which resembles a plaster cornice, but is actually made just from the insulation itself as it turned up, which not only has a decorative element, but is also performative in helping to mitigate against the cold bridge that would otherwise form at the junction between the wall and the ceiling. Lighting, we put in surface-mounted conduits that we could easily be disassemblable, reused. The client could take it to another home, take it down, change it, sell it. The insulation material was made from reclaimed Jeans, a company that collects denim from post-consumer waste in France and the UK, turns it into insulation. And it was all built with screws, mechanical fixings, no glue. So it's a system that can easily be taken apart for maintenance or adapted. Again, it could move with the owner, it could retain its value, or it's just made of cotton and wood. It could be composted or recycled. On site, we had plenty of work to keep track of all the materials coming out of deconstruction. We audited those. We managed to reuse on site directly about half of the materials that came out of deconstruction. The other half went to recycling companies, which I think we can question how effective those really are in the UK today, and a few bags to landfill. We also audited all the materials going into the building. So about a quarter of those came from the building itself, about half from reclaimed sources offsite, and about another quarter from conventional building materials made from virgin sources. making these two windows, had a lot of bricks coming out of deconstruction. We used the whole ones in the garden for paving, and the ones that came out broken put into this gabion wall. Should have made it a bit bigger. We actually had more bricks than we thought. Probably needed to be a thicker gabion wall. But essentially, this was our kind of skip. Anything that was inert was instead of going off-site, was going in the gabion wall. But of course, we managed to make it look nice as well, and enjoyed the fact that meant more different colors of brick than we were expecting necessarily to come out of the building, which was also great for plants to grow up. And even some bits of timber that we put into the top of the wall, we drilled out for insect species which are being used. Smaller elements like the worktop from the old kitchen was a really horrible, shiny black granite. But we just took an orbital sander to it, and it became this really smooth, gray, a lovely product, in fact, in the end. It was amazing that just a simple transformation could turn something that was unappealing into something really nice. The rest of the kitchen and the flooring is from reclaimed oak from Moldavian agricultural buildings. And from an energy and carbon point of view, if we had built this project from typical new materials, I think it would have had emissions of about 4 tons. But the effects of reuse were such that all the materials that we didn't have to buy, didn't have to cause to be made, brought it down to about 2.5. And if we were to consider the effects of timber sequestration, which are potentially a debatable point, perhaps even more debatable when we're talking about reclaimed timber, we could argue that it was a net positive impact for the environment. Operationally, we cut the energy use of the house, the flat, in half, which today I would, it's a few years since we did that project, and I think that's actually not even close to enough. And it's amazing how things are changing, how quickly our thinking is changing. And in fact, these days we would hope to achieve a lot more. Thank you.
Okay, next we have online. So this will hopefully work perfectly. 2 years practice. We have Delfina and Teresa, who will be talking about local raw materials. Delfina has worked as a senior architect, as Zaha did, and was in charge of their first facade package in South America, where she has since moved. She studied at the AA and now has her studio there. Teresa, in Buenos Aires. Teresa also works in Buenos Aires and is principal of La Besa studio, also in Buenos Aires, as I said. So over to you.
Hello, thank you. Today we're based in Buenos Aires. As part of this circularity theme and symposium, thank you for the invitation. I want to present today a studio here based in Latin America, which we collaborate together. I think it's a studio that is very important, and their work is very responsible towards the environment and the materials themselves, how they work. It's a studio that in the last years has been able to work with the integration system, integrating local communities as part of their suppliers, manufacturers, and material producers. And the way they work, I think, is very into a sustainable approach, where the design language is where the materiality and the materials they use to build and design very part of their design language. So today here I have Teresa next to me that is going to present some of their work and explain the way they work.
Okay, thank you, Delfina. Hello. First of all, we'd like to thank the Architectural Association School of Architecture to invite us to have this talk. Thanks to Nacho Marti and Kiran Malik, and thanks to Nicole Michel and of course to Delfina Boca from Mother Studio. Okay, so we are going to, I'm going to read because it's not, I'm inspired if I read. So I will just read. I know it's a little bit boring, but let's try to follow this game. Okay, so let's start. Persuasive Studio is born as a study with a triple disciplinary approach, where a synergy between architecture, landscape, and industrial design is proposed. They feedback and support each other without having a declared privilege. Materiality is fundamental in developed language, and these materials act in an integrated whole. Thanks to having our own carpentry and blacksmith workshop, we can work hand in hand with guilds and crafts and have a completely unusual and close approach to the design of details and prototypes. They are carefully chosen materials of natural origin, raw, that are used in an honest way, without painting or covering them. They are not used as lining. They are structural of the work. Virgin material and reused material coexist in equal parts. The passage of the time only helps. It accompanies the maturity of all the components, the consolidation and settlement of the material, the growth of the plant species. So here now we are going to talk about why we use steel and wood. So steel is I will say it very quickly, everybody knows it, but steel is a construction material that has the most post-consumer recycled content. With this, I mean reused material that has already passed through the hands of the consumer. Globally, at minimum, steel has 35% recycled material. As in that, the largest supplier of steel in Argentina declares this amount. But in South America, there are other companies that report more than 90% post-consumer recycled content. The reuse of existing metallic structures in new structures is a very common practice here as well. Steel is 100% recyclable, unlike other construction materials. It is the only cradle-to-cradle material, which means that it can be recycled forever without losing its initial material condition. And then we use wood. In general, everything is made of steel and wood, the architecture we do. Wood is completely natural material. Trees absorb carbon dioxide and other pollutants from the air and generate the production of oxygen. They filter the air. Mature forest absorbs less carbon dioxide than a young, growing forest. Therefore, pruning, cleaning, and deforestation is favorable to the environment. Wood from sustainable forests generates biodiversity and regeneration capacity. In addition to providing benefits for the people, such as stress reduction, heart rate reduction, lower blood pressure, less anxiety, more comfort. Also, by regulating ambient humidity, it improves respiratory quality. So now we are going to talk about 3 houses we've made. 2 are in Buenos Aires and 1 is in Guadalajara, Mexico. So in general, we intervene in urban areas, in lots despised by the real estate developer market because they are rare, because they are small, because they are atypical. For us, it's ideal, this way of getting to the project. That positively stresses the project, and it gives them thickness and reason for being. Every approach is handmade, unique, and unrepeatable. The initial reflections are empathic with the context, registering the neighboring patios in order to plant our own patios there and duplicate their benefits. It is a recurring thought that after our intervention, the object must have improved at least in its immediate environment. So now this is Casa Clara. Okay, so we're going to talk general things about these 3 projects. We are not going to explain each one of them. Due to our benevolent climate, more than half of the year we can literally take advantage of the interior-exterior continuity, and the ground floors are transformed into large semi-covered galleries or equipped pergolas. I read it too fast. Okay, now these are the plans, the sections. Okay. The vegetation, this is another one in Guadalajara. The vegetation always is native, attracting the local urban fauna. Boundaries are intentionally blurred, and austerity in the use of resources seem inescapable to us. The proposal of the spatial sensibility of a backwater and oasis. Our search is to revalue vernacular wisdom with a contemporary approach, creating a passive architecture that does not depend on technology for well-being. The perimeter wall, the lattice, the siag, the vegetative buffers, the parasol, the good orientation, the registration of the wind, the cross ventilation, the native plant species. Everything makes a belonging to the place where it's placed. And the non-consumption of energy or the dependence on technology to obtain comfort. So this compendium of work was gestating for many years, and it's now, when in a mature way, we can break it down into a series of work which reaffirm us in our design process. Okay, thank you.
Thank you very much. We're coming back to questions after. So the final of the presentations is called Circularity in Construction, and it is with Pablo online, but also Xavier, who is here. Pablo is an architect and head of sustainability at Bryden Wood. With an MArch in Sustainable Environmental Design from the AA, he's worked at Grimshaw, BDSP, and Atelier 10. He's a BREEAM assessor and has a number of projects to his name. Javier is a structural engineer, having studied industrial engineering in Spain, but now specializing in structures. He qualified in 1999 and joined BAC Barcelona. He is now a director and UK manager of their UK office.
So thank you. Good afternoon. We are here, Pablo and I, to explain a little bit what we think about the circularity. Instead of explaining the whole thing, which will be an endless history for today, what we try to do is to give you an idea of the missing gaps that there are on the circle, so to make understandable how it could work. First of all, linear compared to circular, that's something that probably most of us we are aware. We need to shift from the linear thing, which is the one that we have on the left, to the circular one. That means that we need to recycle, we need to reuse, we need to always come back to the same materials and do not impact more the ground or the earth. In here, you can see the Ellen MacArthur half of the graphic that they use usually for the industrial one. So most of us, we are dealing with construction. Of course, we can use biological products, but most of them will be industrial. So it's the blue circle. And here, as you can see, we always need to follow the smallest circle as possible. That gives us the idea of renovating or reusing. And the last of the opportunity will be recycling. Always that we try to think about circularity, we need to understand that retrofitting buildings or try to extend the life of everything, we always will be much better for the earth than doing new things, okay? So as an introduction, or that's the introduction that we will do. Now Pablo is taking the lead on that.
Yeah, so we came up with this diagram that these are our 6 proposed steps to a circular building. The first one is planning ahead. Second one is maximizing reuse. Third is design for optimization, using technology, product as a service, and the final one is minimizing the impact on waste. And this approach can apply to building cities, fit-outs, products, businesses, all the different scales that could be affected by a circular approach. And the point we want to make today is we need to talk about redefining the concept of waste. waste is a resource. We need to be talking about resources all the time. Materials are resources and they have value. If you retain the value of a material, you're retaining the environmental properties and the value of that product. Probably can explain this one, Xavier, better than me.
So yes, whenever we talk about waste, that's a concept that probably what we need to do is to change the meaning of waste. So if you go to the definition of waste is what you can see here. As we saw before with Tom's presentations, or is it here, more or less the numbers that building industry is creating is what you can see in the image is 40, 40, 40, 40. And that's a big impact as an industry. We know that we haven't changed our sector for ever. So we are still building as they used to do. And now we have a big challenge to change everything. And the first thing that we need to do is to consider that there is no more waste and there are opportunities there to use. We have seen Tom using jeans, and we can see other kind of reusable materials. And why not to produce cities that store or that are produced by the waste that the city produce? That will be quite romantic thing.
So the first step that we propose is to plan ahead. This is crucial. We need to define metrics and targets, and we need to come up with a clear plan. What this means, if you go to the next one, please, is in terms of the missing gaps, there's one clear challenge, and it is the fact that it's difficult to quantify circularity. We cannot say whether one building is more circular than the other until we can come up with a standardized way or a metric or an index to say this is the index for circularity. There are many initiatives like One Click or the Ellen MacArthur Foundation, Cradle to Cradle, etc. that are trying, but we still need to find that common ground that enables us to measure. At the moment, we can measure recycle, percentage of reuse, percentage recycled, percentage of downcycle, and that will form that metric eventually, hopefully. The second metric, the second missing gap is being able to prepare a comprehensive plan, a circularity statement. That's something that in London is relatively new. It's a good initiative, but we need to standardize and learn and be able to improve the quality of the plans that are form of the design. This is a good case study. Is the Villa Velpendu by Superiors Studio, because it's a project that has a plan. What they did from the beginning is first identify materials they could reuse and then design the building. So in this slide, you see that there's a lift. There are elements of the timber elements from the cable reels from industrial processes. There's still a structure for a paternoster in the top right, and then they reused the lighting and the elements of those advertisements, the panels, to do all the furniture. And you can see that in the next slide, the end use. So the cladding is made out of those timber elements. The lift is integrated in the studio of the building. The cabinets in the kitchen, they are made of those panels. And then you have the timber and the steel structure that was used. So in the end, I think 90% of there's a 90% reduction in carbon, and 60% of the materials, they come up from reused materials. But what is really important is this diagram. When you design a building, if you forget for a second the items highlighted in red, you start with a sketch, then you go through a preliminary design, you get your permits, then you go through building preparation and the construction. But if you want to design a circular building, you need to plan ahead. And that means that first you need to come up with an inventory. You need to find those materials which are available that will form part of your design. And then it is when you sketch it. Because if you don't do it this way, it's going to be difficult to integrate it. After you have the sketch, you harvest it, which means that you need to identify where they are, you make sure they're going to be available for you, you keep on designing until you collect them and they are part of the final and the end product. The next step is maximizing reuse. The first thing that we need to be able to discuss is whether a building is worth it. This is a discussion that is common in the infrastructure business, not so common as architects, but at least we should be able to say, well, maybe this is not the right building, or it should be different. And it shouldn't be this way because maybe it doesn't make sense and has a huge impact. Then we should consider refurbishing, recovering materials, and opportunities to share materials for onward use. In terms of missing gaps, the first missing gap, in my opinion, is that we need to talk more about reuse. Leti has started the debate, and they released this document that it talks about refurbishment in the domestic area of the construction, but we need to talk about reusing in the non-domestic field as well.
As you can see on the images, there are countries that they are quite ahead of us. So on the right, you have some schemes from Sweden. Sweden from, I guess that it's, I'm not wrong, from 2010, they have no waste at all. They don't do landfill. So they convert everything that we understand as a waste, they convert it in energy, or they convert it to materials to be reused. And even they buy all the waste from Norway. So they are not just processing what they produce, they are processing what others produce. And that should be an example for all countries, because it's the way that we can, let's say, enter to the circularity and as well reduce the impact. If you have a look at what happens in Europe, so here on the left, you can see how the plastic waste has been moved from Europe to other countries. At the beginning, China was accepting everything. Right now, it's quite hard to, let's say, sell our waste in plastic to other countries, but we haven't reduced too much the waste of plastic. So that's a big impact. And in the middle, that's the thing. So when all these things will become a business, every developer will want to go to there, okay? So nowadays, a building that is not certified in environment certifications, and probably in the closer future, if they are not circular, they won't be interested, because there won't be anyone going to there to work there or to rent spaces. So what we need to do is to challenge the industry and make it as a business.
Case study of reusing elements and reusing structures is Hub 67 by Lin Atelier. This building reuses 80% of materials from the London 2012 Olympics, and they use the aquatic center seats, running track materials for the cladding, steel frame cabins are part of the structure, decking and timber as part of the furniture that you can see in the images at the bottom, and the anti-climbing facing was reused as part of the cladding of the material. Another good case study is the Bartlett School of Architecture, which is a reused building. And you can see this is the before and after. And before they actually came up with this scheme, they went through a series of analysis in the next slide, where they actually tested and analyzed different solutions for the facade. This is the kind of analysis we need to do. When we take a building that is old, we need to see, is it fit for purpose? Can we reuse it? Can we make a good use? And we need to quantify the carbon, the materials, the possibilities of reusing from a point of view of your circularity.
So what we can do, so there are many things that we can do, but one is to optimize as much as possible. The optimizations needs to be in a smart way, so we can optimize for optimizing, because then a building or a design will become like a patch of different things. So we need to optimize understanding the holistic approach of the building. And the other thing is that we need to optimize always thinking on that this product needs to be reused in the future. So here there is an example that is quite interesting. The industry of wine or champagne or cava, it's an industry that spends quite a lot in glass. As you know, glass needs to be melted to be reused, or at least now is what they do. And most of the bottles are oversized 5 times of what you need. And it's just because the feeling that the wine weighs enough is what they are looking for, not because we need to have all this quantity of glass. So there is a company that has come up with this bottle that probably it's not as nice as others, but it will depend in the future. So if we can use this bottle that it's a square, that you can stack much better, there is less difficulties to put it in the fridge or to put it in a cover. So and it spends, let's say, much less quantity of energy to be produced, right? Because it's from recycled materials, it's made in an easy way, and you can reuse it as many times as possible. So it's a matter of understanding that. In terms of designing in architecture, there is a way to understand that a project can be with lots of different strategies apply. But whenever you work with the position of the pillars, for example, you can optimize quite a lot the quantity of materials. Or depending on how a precast element is performing, you can decide where you put material and where not, because it's a pre-design, it's a pre-manufactured product. So you can quite easily decide where it needs to be. But as well, there is something else, which is the multifunctionality of products that will be part of the next panel. So all these strategies helps to make everything much more interesting.
I mentioned this project in the morning. The Forge has lots of different circularity elements in the design. So one of it, which is crucial, is the way it's built. Most of these elements that you see that they are temporarily used during the construction, they are reused within the same building, and they are reused in the next buildings that this developer is producing. Also, the structure that is part of the final building is bolted, and all the elements can be disassembled, so they can be reused. And there's a circularity element to that, so it's designed for disassembly. And also, the whole concept of building in layers has been applied across the whole building in terms of the skin, the structure, the services. The point is that each of these different elements, they have a different lifespan. So they are designed so they can be disassembled whenever is required after 10, 20, 15 years without affecting the rest of the buildings. And that means that you don't need to dismantle things which are not necessary. And therefore, you're reducing the amount of waste.
So nowadays, and we had a lot of chats about carbon and all these things, technology is our friend, or should be our friend, to design better, okay? Technology is something that will help us to integrate all these concepts. As you can see here, there are things like BIM, there are things like material passports, or all these kind of aspects that needs to embrace all this new way of building. In terms of missing gaps, what we need to see here is how we will trust all these materials after 50 years, okay? How we will manage all this information, which process every tenant or every owner of a building needs to follow just to make sure that when he dismantles the building, these products can be used in the future. Because what we cannot do is to certify every time a product is being reused. What we need to do is to follow a process and reduce the energy that you need to do all these things. So there are examples like the one that you can see here, which helps you to use technology to produce all these elements, okay? So all these elements has been designed and CNC produced and then mount as easy as possible. So there is something else, which is that let's use as much as technology at the beginning, during the design, during the production, and reduce the quantity of energy that you spend on site. So that means that everything can be mounted and dismount easily. Here there is an example of one of these things. So that's a refurbishment of a building. And what we did was to use BIM technology to draw everything, to do all the drawings and everything, but as well to manage to put all the data inside of the Revit model. So that was a building without any record. And we need to do all the surveys and everything to understand how this building performed. So instead of having lots of paper on documents, what we did was, okay, let's put all the data on the model, and let's put on the model as well all the conclusions of what we did in terms of calculation. That's an asset that takes forever, right? So 50 years later, they can use it again. BIM is data, it's just data. So that's a good example of what we are saying. So that's a building today. In 50 years or more, we will be doing lots of refurbishments in between. It's what Pablo said about the different layers. So how we can make it trust, how we can last all these certificates. So we need to find a life cycle methodology that embraces circularity with the buildings. And the tools that we will be using, for example, are digital twins. We will be using blockchain probably to make it trust, so replicate all this information everywhere. We will need to create a stock market that probably will be worldwide, because if we need to build lots of different buildings around the world, probably there is not enough with the one that is close to us. And of course, the public policies needs to change a lot. We cannot stay as we are.
Product as a service is one other area which is probably less explored in the architectural practice, and it's about rental and it's about take-back schemes. So if you see other industries, they use the concept of renting from clothes to printers to cars, and they take care of that material, they refurbish it, they treat it, they reuse the materials. All you need to do is pay for its use. And a good case study in the construction industry is the Schiphol Airport, where they rent the lighting, is rented by Philips, and they do the maintenance. They recycle endlessly that material and they take care of it.
Another example is a company that wants to be more sustainable. They do lots of mezzanines for different warehouses and they use it everywhere. So what we are trying to do is to explain them that circularity means not only be sustainable, but as well to change the way of you think the business. So if they are able to give a service as a mezzanine, that will include something that is very important for them, is that they will produce a stock of materials that will be spread around different warehouses. And then what they need to do is to dismantle them and mount them in other places forever, right? So that is it's a way, when you redefine the business, to do less footprint. And at the end, just to minimize the impact on the waste, just a second, we need to think what happens with this word, okay? If you try not to use waste, it's very difficult, but we need to train on that. And we need to use low impact materials. We used to change the way we reuse all these materials. As you can see here, as Tom said, jeans is an opportunity, right? But there are many others. There are many other materials. All of us, we know that plastics are insulated materials. Why we are not using lots of plastic on the walls, right? So here there is an example of a building that was made in Barcelona. This is a very quite circular building with cradle-to-cradle certificate. Here is measure all these things, so how all the tones and everything on the materials. And then another company that produce raw materials from demolishment. So they select grains, they select sand, they select gravel, and they produce concrete from here, or they produce other kind of materials with this kind of split. And payments, for example, not only in buildings, but as well in infrastructure. Sorry for the time. There was a lecture about it, and it was quite interesting how you can take advantage of all the streets and all the roads. And here there is an example that will be running on the background. Is more or less a video that is not working. Well, there is a building in Belgium that they are demolishing. They take all the demolishments and they are doing the new building. That's the World Trade Center, okay? That's it.
So now for the conversation, for which we're going to be joined by Mary, who, if you'd like to come and join us at the front. Mary is a senior associate at ECD Architects. She's a passive house designer and has an expertise in higher education, both new build and refurbishment. Also joining us, Toby Allen. Yep. Is a structural engineer with a great breadth of experience. Amongst his specialties is timber buildings and modular construction of these. He's having worked on a number of leading practices. He now leads his own design practice, Studio Allen. So if possible, I'd like to invite one of you two to ask the first response to those talks.
Well, maybe I can start with a few thoughts. First of all, thank you for the presentations. The three of them were very interesting and really good projects. So thank you very much. And then particularly on the third one, all I would say is I couldn't agree more. I think it's obviously, we know where we are, we've got the destination, and we have to forge a path to get there. And the circularity industry is very much in its infancy. So we really need to find that path, how are we going to get there? So it needs to be planned and the path has to be made because it's non-existent at the moment. So one of the things you mentioned, passports, building passports. And together, I think hand in hand with building passports, we can also think of building banks. So this idea of having a bank of materials whereby before I start designing a building, I can go to that bank, look on the web, check what the assets are. I need a steel beam of dimensions X, Y, and Z. So I can, this is what is available. So maybe my space can be, this size to suit what is available. So it's another way of thinking. We have to have a different mental, way of thinking, because it's, imagine a world, I always say, imagine a world, if you were to close your eyes for 2 seconds without falling asleep, imagine a world where there are no more materials. Imagine that, no more materials. What would you do? You would have to design with what we currently have, which is the building stock. So if we had material banks, we could, before starting designing, we could look, what is available, where is it, what transport, how far would I have to go to get it? So that opens a completely new industry that at the moment is pretty much non-existent. And it's an opportunity. It's an opportunity, if you want a business, if you want to make money in the future, this is an opportunity. It's also a challenge. And the great challenge with this is certification. You all know about it, but obviously I'm a client. Imagine I'm a client and I'm going to be buying something that has been used in another building. And I mean, with the steel, it's probably a bit easier. But if it's timber, who is going to be certifying that this timber that is 100 years old, if it doesn't have dry rot, it's up to scratch, I can use it safely, etc. So the real challenge for reusing materials is certification. And in the first project, I thought it was very interesting because you were the client. So it was your own house.
No.
I thought it was your own house. I misunderstood that altogether.
Okay.
So
I think that was because in one of the photos you didn't have any shoes.
Oh, yeah. I thought it was your own house.
Just the photographer's model.
Apologies for that. I thought it was your own house. Okay, but anyway, your client was obviously prepared to take risks. And you need clients who are prepared to take risks. And depending on how big the project is, particularly with all the fire issues we have been, with Grenfell, etc., there are risks at the moment that some clients might not want to take. So the big challenge with reusing materials, it really is certification.
And the insurance companies.
Yes, insurance. Yeah, quite right, absolutely.
Are the ones that lead the market.
So, and then the idea of obviously building material passports is a fabulous idea because we can, what do you have in a passport? In a passport, it says when you were born, where you were born, the color of your eyes, where you are going, where you've been, what countries you've been visiting. So it traces who you are, it's your identity. And that's what, with the passport, a material passport, that's what it does. It's actually telling you the story of a material so you can hopefully use it in an intelligent manner, in a safe manner. But yes, the big challenge is certification.
Let me respond or not? Pablo, I take the lead now if you want you later. So I think that we need to think on mass passport for materials, but as well passport for buildings,
yes.
Because it's the way to involve all these developers, and that will be a business in itself. So if you have a passport that is very low, let's say, your building will be much rated, and that means that many people would want to be there. So we need to think that material building passports is what we need. Is like the energy certificate. Yep. So at the end, that will embrace energy, that will embrace embodied, and it's the way the government can push further the investors to invest in circularity. And that's the key point, and we need to establish it as soon as possible.
But currently, we have a situation where after, I believe it's 12 years, you do not have to keep any record of the building at all. We just looked at a building where the company that was holding the record said, "Oh no, that we binned it all 6 months ago." Do you think we should therefore push to a situation where you cannot sell a building of, obviously not domestic would be difficult, but say a commercial building, you can't sell a commercial building without a digital asset of it?
Yeah, absolutely. So a building nowadays is a responsibility that an owner has. And the responsibility is not just for building it and exploiting it or using it. It's as well a responsibility of the end of the building. So whenever they sell the building, they need to sell all track information, all certificates, and as well all the digital or the kind of information that we decide that it's the good one. And as well, all the methodology that you have followed to keep all this information up to date. So you don't have the certificate, you cannot do it. The same will happen when you want to demolish a building. So you cannot demolish a building if you don't have all this information, but as well, if you are not able to locate all these materials to other places. That is happening nowadays in Sweden. So you cannot demolish anything unless your survey of demolition allows you to say, okay, I think that is 70% of the products are already allocated in other places. Because imagine that if we demolish one of these skyscrapers that we have in London, where you will put all these materials. Mm-hmm. It's crazy. So there is no land for doing that.
I just wanted to can I bring in Toby first? Is that right?
No, I was going to respond to that point. Go ahead. No, go ahead.
Thank you, David. I mean, I think, yeah, fantastic presentations. They're all following a similar theme, but very, very different. So I think the variety there was fantastic, was amazing. I think just responding to what you're talking about with the data and the knowledge, I mean, that has come on massively in the last few years. I mean, we really, you could not recognize the amount of information there through the BIM and through all of the tools that we've got on board. But I do think, from a structural perspective and an industry perspective, there's some bigger things at play here, isn't it? It's not just kind of getting the tools and getting the knowledge and kind of like cajoling people into it. I think, if we look at the way that the industry has contracted over the last 30 years in terms of service, this is a fantastic opportunity for us. And I'd echo that opportunity to push ourselves back into the areas which we really should have more of influence over. Our little linear kind of like value chain that we were kind of engaged with and been pushed into, we can expand that. When we're looking at the circular thing, I think looking at these materials and where they're coming from, looking at what we're doing at the end of it, I think that's fantastic. Because I think as professionals, that gives us an opportunity to really widen our exposure, and there's kind of 100 times the kind of like the influence that we're going to. So I think that is a huge positive. I think one of the things that I find very, very, very interested in terms of the waste, and going back to that kind of like issue about the waste. I mean, 60% of waste coming from construction. I mean, does that not like I have a kind of like a sharp intake. I'm thinking, gosh, I'm kind of involved in that because I mean, the construction thing, seeing the skips. I mean, I did my house last year. It was my house, and I was building this extension out of CLT on a 1930s. It was a fantastic experience, and I've still got bits of timber in the back garden. I'm still kind of going into and kind of creating furniture out of, which I encourage anybody who's got that kind of to have a go. I think the practical side of it is fantastic, but this waste issue is huge, and I think one of the perversities that I find, or I think is shocking in a sense, is when I was working for somebody. In fact, it was my brother. He had a house that he was going to refurbish, and it was actually cheaper for him to knock it down and rebuild it than it was to reuse the building because of the VAT. I mean, that is just mad, absolutely mad. And the other thing is, as a design professionals, it's cheaper for developer or for clients to build to go to a design and build person who's, no disrespect to any design and build kind of contractors in the room. I don't think there are many, but anyway, but they will return to their established ways of practice. Whereas in fact, all the things that we've been seeing on the board and all the kind of like things, it's like this takes thought, this takes planning, as you pointed out. This really takes a kind of like a design professional to something where, and the fact that they are getting a VAT kind of like bonus for not employing a consultant and employing us all the way through is also absolute anathema to us. So there's things in policy which really just need to be addressed. Why are we 20% more expensive to do the right thing? Why are materials which are kind of coming from who knows, these places? Why is there incentive there? So I think we've really got to look at the wider picture as well, because I think there's things that we can do as an industry to kind of like lobby for it. I'm passionate about timber. Timber's not going to be the gold and whatever, but I do think so. Sorry, David, I'm going on too much, but I just really love the way that we're focusing on waste as well.
Well, I actually wanted to bring Tom in on exactly that point because we're too close.
That's all right. It's fine. Kieran's gonna.
Just want to bring Tom in on that because what part of it is, we could see that the contractor was so heavily involved in the whole process. So I wanted to ask you, Tom, on that. How does the contractor have to change their mindset? The old approach had to be about having a very clean site at all times, because health and safety, direct correlation between accidents. And so, you use a piece, you put it in the bin. You order the exact same thing the next day. That combined with the fact that it's typically a very low margin industry. And so they revert to form because they don't want to try anything new because they're already working at 1% margins and things like that, or negative margins if you work on large government contracts. So how does the contractor role have to change?
Well, I think what's emerging from our dialogue at the moment is both questions about what we can do now that take steps into this direction where we want to be, but also what's been discussed earlier is sort of imagining of where we want to get to. And I think there's still a very big gap. Maybe there's something that will come out of other topics of how do we, instead of making incremental little changes, actually start to forge that path and actually get to substantial change. And perhaps policy, VAT, lots of those are also on our minds as well. In terms of the construction industry, I think even on a project at the scale of a flat, it took a kind of unique dialogue with the contractor to say, in fact, to agree to a fixed contract sum, despite the fact that there were a number of unknown elements that they were going to be deconstructing this building. They weren't sure what they were going to find. They were going to reprocess them on site. They weren't going to be buying new bits of timber from a company where they could predict the price of it. They were going to be reprocessing it with X number of man hours that wouldn't necessarily be known up front. And in our case, it just took the willingness for client, contractor, and architect to work together and say, well, this is what we want to achieve. We'll find a way. Even though that was a very different way of pricing and understanding a construction contract, and that we would share the risk and work our way through it.
Yeah, because in procurement, if you think about it, if we have to, at the end of the life of a building, where we are going to deconstruct that building, how are we going to do that contractually, for example? And also when you start, another thought is when you start a new project, thank you. When you start a new project, would you, on a stage, at stage 0, would you bring a specialist in deconstruction? So somebody, you've got an asset, you've got a building. Would you bring somebody around who says, actually, you can pull that down without damaging it. However, if you do that, you're going to create damage to that building, that material. So is there a potential role for another designer in the team who might be maybe a specialist in deconstruction so that we can reuse materials?
Pablo can answer that.
Pablo.
Well, I was actually thinking that I completely agree. And in a way, there's already something about the requirement to bring a specialist in demolition that is brought by BREEAM. I know that BREEAM, we think that is not the holy grail of anything, but it has some positive things. And if you do a BREEAM project, you need to bring a demolition contractor to do a material database and try to find opportunities for each of those materials to have a final end, a positive end, hopefully. So I think that's a good starting point. I think we just need to make it a bit more integrated into the design. But this is definitely very important, that when you're doing a project of a refurbishment, we bring that knowledge of a specialist on board.
I'd like to also bring in Delphine here, because I think I'd quite like to ask you on that same topic. How do you think the work of an architect has to change in this process of bringing in the circularity?
Well, I can start. I think maybe myself and Teresa also has another opinion. I think an architect today is the way, we work in this studio. It's someone that has to deal with a lot of things at the same time. So it's like a multitasking role, I think. So the role of the architect each time needs to get more specific in different aspects, and then your knowledge needs to be much more broader. So Teresa, what do you think?
No, I was thinking when I was hearing the lecture of the other opponents, that we have here, we don't have a regulation that is a law that you have to do this certification to build. But we've been doing this for 20 years now. For example, in Casa Clara, I was thinking all the time when you were talking, and we've used all recycled materials for a thing about the cost of building. It's cheaper here to buy reused metal structure to build, and all the materials are very simple and very cheap. So we've done this architecture in the beginning with a very few resources, economic resources, and reusing a lot. The wood as well. We use certified wood for our industrial time, and we have this concept. It's not obligatory. It's not a law, but we do it because we think it should be made like that. And we have this year we have a consultant in sustainability, and we are teaching and we are doing internal symposiums and courses to teach everybody we too to learn this way of doing things. We are happy to be in circularity symposium to bring it to our architecture even more.
Thank you very much. Kieran, would you like to ask a question?
Thanks. Wait. Hello. Okay, it is working. Sorry. So I was going to say, I think Tom did a really good job of avoiding a question earlier. You managed to do your project in a circular way, and I was just really curious, like specifically, like how did you have to, as an architect, get more involved in designing the construction process, like where different things would be going on in a limited space, because it was a really limited site that you were working with. You could see at points where they were very cramped, but they were still working. So did you have to get more involved in that? Did you also have to like discuss with the client about acknowledging that processing the material might take more time, so you allow for more time in the program? Like, how did you have those kind of discussions with how much more did you have to get involved, and how did those discussions kind of go in the process?
Well, I did live around the corner from the job site, and the contractor did call me every night for the entire duration of the build with a question. So it was hands-on, that's for sure. But there was a lot of willingness from both the contractor and the client to make it happen. And that actually, I think, comes back to something earlier on in the process. You know, during our initial designs for the project and first sketches, we weren't saying this is a reuse project. We were thinking it's about timber, or it's about sustainability in some other way, or about embodied energy. But then we had this one conversation with the client who said, I can't stand the fact that I'm about to tear up and throw away my kitchen. And we're like, and you have this moment where you suddenly find what really resonates for them and what resonates for us at the same time. Then something is really possible when they're completely on board, and then finding the right contractor who could also get it. And then, then actually those kind of issues about managing materials, cramped site, taking extra time, they kind of go away because there's this basic buy-in and interest in what we're trying to achieve.
So is that the trick to it? Is that you started off by noticing that there are materials in the building, then designing based around those materials, and then having that nice moment where you kind of discovered you could use those materials there to do the same job? Yeah,
I mean, that happened in terms of design, kind of bit by bit. There were things that happened. We knew we were going to have lots of bricks. We knew that we needed to do some paving, but we didn't know what else to do with an awful lot of bricks. So the gabion wall became a kind of great place to kind of throw all the masonry and lots of other inert materials, and actually the most economic element, the part the contractor enjoyed, not having to order 3 skips to get rid of it and just put it there, just right there, and right next to where you're working. Other elements, were more in the design process, and thank God we have contracts where we can make design changes during construction, and we can say we've got these extra windows. We never drew the glazed partition onto the stairwell. That was a choice of something that happened halfway through construction.
And I think this is a fascinating kind of illustration of how, being on hand. I mean, so some of these decisions, some of these plans could be made in advance in our designs. I mean, we need to set off in the right direction, but also on sites. I mean, if you're there and you physically can see the number of skips that are kind of coming outside of that site, and thinking about all the materials that are being thrown away, things that could have been done differently, I think that's where we can really start to tune in onto these issues. And I think as designers, we need to be out on those sites. We need to actually understand what is physically going on and how we can actually influence it. We need to have a real radar of cost, a real radar of time, a real radar on these materials and what actually is going on and what's being thrown away. And I think we need to tune into that. And I think that again is the way of throwing ourselves further and wider than maybe we traditionally have been pushed into, because I think need to know how this stuff is actually being worked through on the sites that we're working on.
I think more connected as well, because there must be so many materials coming out of buildings in London right now, going to landfill, going to waste, being incinerated, which I would take issue as not a useful conversion of Sweden might say they don't have any waste, but if they're burning it all, that's a bit questionable. But could go into products, and we need access to them. And I think that's a step that perhaps could be implemented quite quickly to actually have a kind of centralized inventory of materials that are becoming available, and then create an opportunity to start using them.
The issue with that obviously is, among other things, we talked about certification, but also transport. Because obviously, where do you keep them? How long for? Place for the storage. So what is a simple idea, when you start putting it into practice, it's actually can become quite complex.
I have a theory on that, which is that I don't know if it will work or not. Okay, but my theory is that we have lots of ships going around all the seas and everything.
Yeah.
These ships are always plenty of new raw materials or new products that are being transported. So if you think a little bit on a moment that we will be all circular, all these ships can be plenty of products that are going to different places, probably not all of them with an owner, but they are containers of already used materials from demolishment or from these dismantlations. So in a way, when we say, okay, I want to dismount this building, I need to allocate all these products to someone else, but there is a percentage that you never will be able to do it in one shot. So the government will allow you to do dismantlation, and then what you need to do is to locate all these products in containers and then put it in a ship. And this ship at some point will go to a place that, because there isn't a stock market on the background, and people can collect all these products by the stock market, you can see even where this product is going on, right? So because there is a GPS that tracks you the place. So there is a whole bunch of industry, as you said. If you want to do business, let's set up that, because that's the business, not the architectural one. Yeah. So Tom has done a very romantic project, but I'm sure that the business there is very difficult. Yeah. And probably the owner of this flat, I don't know if he pays a lot or not, but he was all the time in risk. So that's a big issue. Whereas all the background, all the industry needs to change a lot. And as Pablo said during the conversation, we need to redefine the business in a way that all suppliers change. So instead of buying windows, we need to buy a service of a window, because if I'm the owner of a building and I want to dismantle the building, what I will do with a window? Yeah. So I'm not responsible for a window. I need a service. I need someone that takes the window, rearrange it for another one, and then serve it again. So the whole sector needs to be redefined. But we need to be prepared for when all these things happen, which is when we will be circular. But there are 50 years in between that we are in nowhere, that we need to understand how that will work. So there is two different definitions.
We have a question from the floor.
Hi, sorry, I think some of it were already questioned and answered from the discussion just now, but I had a question about dealing with when you're reusing a material. It's good, the ideal situation is you reuse it on the site, but of course there's going to be a different timeline and different kind of locations. And so how do you deal with materials? There's always a problem of storage. So how do you deal with that gap between time and space, and how do you make it even more local?
Yeah, I'm just going to make sure that's been heard online. So, it's a question of, so if you're taking a product from one building and then you're going to reuse it, how do you deal with the time aspect of that? And I think I could echo that actually on a project I worked on. The CLT cost for this was new CLT was £4.5 million. There was a program delay. No one can guess the project yet, I guess, by 18 months. Yeah. And the storage cost was £1 million. Yeah. So there is a significant problem with the logistics that you're talking about. So yeah, that's the question. Who would like to go first?
I don't think there is an answer at the moment. That the industry has to develop that precisely, because at the moment it can be, reusing things can be far more expensive than actually building new. So, and program is an issue. A contractor is not going to be waiting for 9 months or, until material number X becomes available. It's the sequence of when, how he's building, and he needs the materials now to follow that sequence. So the whole issue of program is a very difficult one. And I don't think we have an answer at the moment. I think it's something that we'll have to develop and, pilot different ideas, but I don't think there is
I would like to reinforce the message. So nowadays in London, if you go for planning application in a plot that is an existing building, they don't allow you to demolish it, okay? So the developer needs to redefine its business just to adapt, to do an extension or to do something on top of this plot that already exists. So if the developer needs to adapt his business, we as an architect or designers, we need to do exactly the same. So the kind of designs that you will do will be based on what Pablo said, which is what is available and what is not. So it's not about free design. It's about what is possible. And I think that that's the shift that we need to do in terms of design.
Yeah.
Okay.
Maybe circularity is the new vernacular, whereas in the past we had to build with the clay under London. Tomorrow we'll have to build with the remains of the buildings that exist today.
But I think that there is something interesting on that, which is that there is a lot of waste around us. So the industry and the technology needs to make available much more quantity of raw materials coming from materials that are not nowadays used for buildings. And honestly, the romantic view of seeing a city that is being built with waste that the same city is producing, I think that is a very powerful idea. Okay, and there is a lot of option there to reuse all these things.
I think you've got to, I mean, creating markets for reused materials is not going to happen straight away. But I mean, there are materials when the monetary and the kind of like incentive is there, that they will be reused. I mean, steel is, 95% kind of reused because it just makes sense to try and reuse that material, or not reused, but recycled. It's recycled and reused. So that you've got to get the finances, got to get the monetary products right, and you've got to create it. It's got to be fostered. I mean, I lived in New York for a while, and in New York there were these thrift stores for kind of reused furniture, and because there were so many of them, and because they were so preferable, everybody was quite accepting. They would go out to the thrift store and buy their furniture, and that took a long time to get to develop. I'm sure it wasn't overnight that everybody thought, I'm going to get my furniture from the local thrift store, but that's what they had in New York. And I think we've got to somehow kind of like put our kind of like yes, I'm sure if you went into a New York apartment, you thought, that bit of furniture is lovely. I mean, I got it from it's about kind of like creating momentum and finding out actually these materials could be recycled, all those bricks could go into a salvage yard, or these things could be going, and it's about kind of like creating that kind of like demand and maybe incentivizing it in some way monetarily, because over time it will come about.
Javier.
Sorry, Pablo suggested that there should be this demolition expert. I think that demolition expert, if it's just simply expert in the actual removal of materials, I think is not enough for us. I think that demolition expert has got to actually be very directly involved in the planning and programming, because generally you were talking about tall buildings. Tall buildings have got a capacity for self-storage. When you actually demolish something, you make a hole in the ground, the contractor's got no place to put his cabinets, he's got no place to do anything at all. Whereas the reuse of a tall building, you've got lots of storage possibility in various forms. Now, the logistics of it, which is fascinating, is very attractive. Now, who best than the demolition contractor in there? So I think we need to find or redefine that demolition contractor, because the ball and chain type of idea of the demolition contractor is nothing to do with what you're actually defining. I don't know if Pablo wants to elaborate on that.
Actually, no, I was just thinking when you were saying this, that maybe it's not a demolition contractor anymore, it's more a big data specialist that we're talking about, because we're talking about a huge problem of information. And yeah, resolving is difficult. So it's probably not a standard or conventional demolition contractor that we're talking about. We are talking about a completely different scale of a problem. I completely agree.
We are doing a massive project in Saudi, and this specialist is called constructability specialist. So yeah, because whenever you think on how you need to build something, at the same time you need to think how you will dismantle. And I think that that's the key point. So we cannot see it as a separate specialist. Should be the same that is building the project, because if not, you lose the track of everything. Of course, can be two different persons, but at the end, the same process that you use for building it needs to be able at least to be dismantled we had this discussion with Pablo. So we need to think that a building is a container of different layers. So these different layers will be mount and dismount many times on the whole span of the building or lifespan of the building. So that means that the stuff, so all the furnitures and everything, that will change every 5 years in an office building or in a hotel or things like this. So that's the easy one. But whenever you go to the finishing, so the fit out, or you go to the services. So nowadays, if you need to change the services of a building for doing a retrofit, you need to scratch the whole building. That's ridiculous. So, and we have these laptops or these machines that you can plug and unplug things. Why we cannot do that in buildings? So that's the kind of things that we need. And that's why we call it constructability aspect, which means that I need to build a building with lots of things inside that I can unplug and change it and amend it or whatever and plug again. And that's the thing.
On that note, I'd also like to add something that it's only an idea, but perhaps, when we submit the health and safety packs to the contractors, we should have their demolition drawings. Whenever we do a project, part of maybe what you have to submit to building control or to planning should be your demolition drawings, i.e. you've thought it through, this is mechanically fixed, you have fixed it in this way, whatever. So it can be part of, to help the process.
We have 2 minutes. Good.
Sure. I just have a quick one for Teresa. She was saying that actually the materials where they're working were much cheaper. So actually the idea of reuse was much more attractive. And I was kind of curious what's going on. Why is that like a thing there? And like what particularly of that place enables it for it to be cheaper and that we could kind of learn from?
The material passport is the solution.
No, but I want to know what they're doing. You can tell me your solution, but I want to know what they're doing.
Teresa, do you want to pick that up?
Yeah. Did you hear that?
No, do you mind repeating?
Sure. I was just saying that you were saying the materials, reused materials where you are is cheaper. And I was just kind of curious why, like, what is it? An availability of space or a lack of new materials? Like, why is it cheaper like to get these materials where you are? And what could we learn from that, I guess?
Why is cheaper? Because we have a parallel market, and here it's a good deal if you buy reuse in it. I mean, they are in good shape, the materials. If they are okay, it's cheaper for us to buy reuse. And so it's very simple here. Here it's cheaper to build in a reused way. It's not like in Europe. In South America, it's like this. And we really exploit this for our design language because we think that the materials are noble materials. They have a long-term life, and we really appreciate this as a design language. And here, people are starting to see this kind of designing. It's a little bit kind of new, and we don't want to intervene so much. The materials are really raw materials here. We have, in Casa Clau, we have a wall that is made of wood. It's like 5 inches wood of white, and we use it like this. And because of our climate, it is possible. I know that it's not the same climate conditions there in London, but in Buenos Aires we have a very good climate, so we don't have so many regulations about this. But we really think it's a way of approaching the architecture and the project and a way of living. I would love to show you where we are, but then we do a tour, a virtual tour. But we live like this, we work like this, and it's possible here and in Guadalajara, for example. We know in other climates it's a little bit difficult to do this.
Did you describe it as a parallel market?
Yes.
A parallel market.
What does that mean?
because when when the contractor, the demolition contractor comes to the place to demolish a building, for example, you can be charged 1 month if you want to keep the waste. And it's cheaper if the demolition takes all the waste, because he delivers in different ways this demolition waste. He can sell it, okay? So it's cheaper for us that the demolition is the one that distributes the waste, and it's not more waste. We use everything, you know, we use everything. So the economy affects the architecture. I think here in circularity, it's a good way of affecting the architecture, because it's business. I mean, it's okay. Everybody wins more if they reuse.
I think that was a great way to wrap up the conversation. Very wide-ranging and multifaceted, to just as the topic is. I'd like to just say thank you to our speakers for all their efforts and for coming in, and as well as our responders. So thank you very much.
Thank you.
We'll be back at 3:30.
Hello, everyone. Welcome to the fourth and last session of today's symposium, Practice in Times of Climate Crisis. This last session is about design culture, and I'm joined here today by Laura Gazkarate, architect and acoustician, and tutor in TS4 and TS5, Ana Mestre, architect, also in practice, in back engineering, also tutor in second, third, and fourth year for that. We joined again by Xavier Aguiló, structural engineer, principal at BAC Engineering London, and tutor in fourth and fifth year in the ETS. Giles Bruce, architect and principal at A0 Architecture, also teaching in many different years, first, second, fourth, and fifth. You're missing third. And Giancarlo Torpiano, structural engineer, graduate from the Emerging Technology and Design program in practice, and also teaching first and second in third year. Welcome, everyone. The first presentation is by Xavier and Ana, if you want to take over. Thank you, everyone.
Hi. So, so far during the day, we have seen such appealing presentations. I feel that all of us are trying to go a step forward in our professional commitments, engaging with communities, with the environment, trying to create value, and above all, having energy efficiency and sustainability in mind. Multifunctionality is what Xavier and myself would like to share with you today. Multifunctionality is part of our professional journey in going further in building engineering. We looked for a definition. This is what we found. This is one of the many things we found. You can read, it mentions multiple functions, it mentions minimizing, it mentions optimization. In earlier talks today, many of the speakers have pointed out some of these words. So I wrote down that Joanna said that we should minimize by using less. Also, Tony said we should aim to get more from less or with less. So for us, multifunctionality is trying to make the most of engineering materials or solutions with the aim of simplifying and reducing the overall footprint of construction with everything it implies, which has been discussed all day. We'd like to walk you through 3 buildings projects where we think multifunctionality was at its core. This is the ICTA project, a research center in Barcelona by Data and Architects. It was our starting point in bringing multifunctionality into our work. This is the image of the structure. We'll go back to it by the idea, the idea of the structure was for it to be optimized. It was our desire and it was the architect's desire. So the idea of optimizing it was to make it lighter, and we thought of voiding it to eliminate material from it.
And by looking at this picture and starting to have a holistic approach to building engineering, all the design team thought, why not use these voids, these empty spaces for the project itself? So if we go back to the original picture, these ducts that you see are actually the element that void the structure to make it lighter, to optimize it. But then it's also a new space for things to happen within this building, such as cabling goes through it, air is transported and moved through it, and any other things that technology will bring us in the next 10, 15, 20 years. So this building, this structure, the skeleton is now, or the structure of this building is something more than just the skeleton now. It also moves the air around. It is the container of the MEP solutions, a closer look of this. Having this building in concrete, having the structure in concrete, we thought of giving it another layer of responsibility. So we used this dimple sheet on the formwork, and the result of using it was, as you can see here, that the exposed concrete was also used for acoustic reasons, to help in the acoustics of the building. Also, it was an activated floor. So again, it's the skeleton of the building. It is the MEP support. It helps with the acoustic, but also with the thermal strategy. You can see on the right the image of the finished soffit, and you can see a very organized set of holes. So it supports the lighting. It supports the speakers. It was all, of course, the whole team was holistically on board, let's say. So the result was very. The layout kind of showed that there was a name from all the team of organizing the project, the MEP, the structure, and the layout of the building. Again, because the building had two basements, we had to solve the retaining system. So we had to put a retaining wall. And again, we thought of multifunctionality. These are images of the retaining wall. It was made with these pie planks. The reason being is that it not only retained the earth, which was the idea, but it also allowed, and look at this beautiful picture, it allowed the air from outside to be taken down to the second basement, which we know, and we've been discussing this earlier, soil ground has special thermal conditions because it keeps a stable temperature. So we would use this retaining wall as a channel to take the outer air into the building and use the chamber that we already needed for the sewage and the control of all the building systems to temperate the air and reuse it into the building. So this was our first professional experience. The starting point was the structure, was the optimizing the structure by emptying it, but it ended up being the structure, but part of the thermal strategy. It was exposed, so it was used for the acoustic and embedding the MEP. And that chamber, which was necessary, was also used through the retaining walls for the air intake and later reuse.
There are two more examples. This one is probably a step forward using all the references that we did in the ITA project. In that case, we are leading as well the MEP, and we are leading all the water cycle. And that's the first slide. So in that case, the building has a green facade. This green facade is being used to clean the gray water. So all the gray water goes through all these plants that are on the facade. And at the end, what we collect is clean water. All the cycle is more complex, but it's not the purpose of this presentation. So, but that means that we are reusing all these facade for other things, because the facade is very green, because the weather in this position, which in this place, which is Rwanda, allows us to do it. But as well, we need a lot of shade on west and east facade, because the sun there is crazy in these facades. North and south is not a big problem because the sun is very high. So the multifunctionality of the facade is multiple, is cleaning the water, but as well is helping on shading the building. Again, we're using this hollow slab. Now we are in construction. We are at the first slab, which is the ceiling of the basement. So we are not yet there. That's the picture of the other project. But on the left, you can see the scheme that we are using. So again, we are boiling the slab, but we are moving all the air through the slab. And at this case, what we are doing is to cool down the slab during the night and use this temperature to store on the mass of the concrete. So that means that it's like a battery, and the building runs like a thermal battery during the night, and during the day is being expended or used. But again, when you are in countries in Africa, you need to be quite smart deciding things. And in that case, we need to save as much as possible the quantity of cement because it's so expensive. So we try to solve this rough foundation with a waffle slab. And at the end, because we need to store lots of water from the rain and from other places because of the policies, but because as well we have all this water cycle, we use all the big waffle spaces on the slabs to store this water. So it's another way of doing multifunctionality for all this slab or all these foundations and the use of all these voids. The building, as you can see, is plenty of these green facades, and hopefully that will happen. And again, it's a beauty thing. So we said that was for shading, we said that was for cleaning the water, is as well the beauty things. And depending on the season, the colors will change. So it makes the building alive. So here we have similar strategies shared by ICTA and Novelia because they are siblings. But in terms of structures, thermal, exposed, all these things are more or less the same. We contain everything inside. We include the water tanks on the basement and the shading system for the plants. The plants are like a buffer between the facade and the enclosure, and the plant cleans the water. And the last experience that we want to share is a project in Madrid, which is the Metro headquarters. In that case, that was a competition. And as you can see, it's a massive building surrounded by others, but at least that one is the one that is built. So the scheme is the one that you can see here. We need to finish all the others, but that one is already there and it's running. So the idea here is that the multifunctionality happens mainly on the systems that are shading the building, which are all the ribs that you have on the facade. And these ribs on the facade are not ribs, are the structure of the building. So all the strategy for this building is that all these ribs that you have on the facade are the structure for every level that transfer all the loads to the lower levels. So at the end, again, there is a strategy of multiple things. Here we can see all these ribs on the facade that are being transferred on the lower levels. We have this structure that connects with the ribs, and this structure that is connected with the ribs at the same time are like radiators because they are thermally activated. Another interesting thing of this building is how the structure goes directly to these ribs, because everything is organized with, again, ribs on the slab. And these ribs on the slab allow all the MEP very well organized, very well set up, and following the thermal strategy of the building and the ventilation. So it's a way to understand. That's the type of the slab we are just finishing. As you can see here, it's a way to produce a slab that has holes between ribs, so allow us to embed the MEP, but as well to move transversal to it. So everything happens in the thickness of the slab, which makes the building much more efficient in terms of height at the end. Here, there is a summary of everything. So a structure again, the shading system, the thermal because everything is activated, exposed because everyone can see it, embedding the MEP, the acoustic. So there is a reduction of a flat slab of 5 times, which is amazing. And then all the shading and evaporation on the inner plaza of the whole complex.
Thank you.
I am here today to talk about a reinterpretation of the round plan of nowadays. So first of all, I'm gonna start talking about what is round plan. In 1930, Adolf Loos contributed to a theory and criticism of modernism by developing the round plan. He said that his architecture was not conceived in plans, but was conceived in spaces, in cubes. He didn't design floor plans, facade, or sections. He designed spaces. So for him, there were only contiguous and continual spaces, rooms, and the stories merged and spaces relate to each other. In Villa Müller, every space required a different height. And he tried to achieve spatial interaction and spatial austerity. So basically, he he tried to differentiate the height of the ceiling in every different room. He was really concerned about the privacy in each room that each room should provide to the whole project. So the creation of room sequences with a special importance on the visual connections of the room was really important. So in 2000, around 2000, we have this example of a run-plan house in Madrid by Alberto Campo Baeza, where the spaces were double height and intersect with each other, producing diagonality, which was also helicoidal. This concatenation of spiraling double spaces were created a connection on a vertical displacement. So my question here, well, at the end, different heights of the ceiling, in conclusion, like different heights of the ceiling cause a breakthrough of the established horizontal layering of the house. And my question here for you today is, how is it translated in terms of energy nowadays? We as designers are concerned about spaces, so hence the energy demands that require each space according to each function. We have passive strategies that aim to achieve efficient buildings. So the passive strategies involve reducing the energy demand, enhance the natural daylight capture, minimize the mechanical systems, and try to maintain hydrothermal comfort conditions for the building. But they also, these passive strategies also involve acoustics in terms of sound insulation, acoustic privacy, and of course, providing an appropriate reverberation for each function. Now, this is an example of a house that I did recently in Spain. The house was really difficult in terms of arrangement because the site was really longitudinal. So in order to enhance for the natural light, we had to design this longitudinal. We had to have a spatial arrangement that was really longitudinal. So that created double height spaces with reflective materials to enhance for that natural light to come into the space. But so we needed to accommodate indoor conditions at that point. So what can we do? We designed, for example, a library, or we played with the furniture in order to provide diffusion to the space, so to compensate the other reflections. And also we merged the thermal strategy, combining acoustics and like isolation for both in the facade. This is another project where I was involved in BDP. So it's the Central Foundation Boys School. It was a refurbishment, a collection of existing buildings in Old Street roundabout. The proposed redevelopment tried to allow for more efficient use of the building. We did the environmental team at the end, as we do in many projects, is to calculate the active strategies that need to satisfy the energy demands space by space separately, as we have done so far. Right, but my question here is, are we then ready to adapt new contiguous spaces to different functions if we calculate space by space? In 2020, I worked in this project as well. This is the office headquarters and laboratory complex in Cambridge for AstraZeneca. This building was aligned to the ambition, the zero carbon program, and it provided this roof provided natural light to the interior as one of the strategies. So what we had to do is basically accommodating this open plan space, these double height spaces to the acoustic requirements, controlling reverberation, and trying to provide a comfortable environment to face telephone conversations and the program. We did some models, and in order to create distinction between two areas, so the inner ring and the outer ring of the project, where we had breakout seminars and the outer ring where more concentrated environments were preferred. Right, so what's going to happen in 2050? Is every individual space considered going towards passive architecture? A building as a whole, this is what's going to happen in a few years, right? The passive building targets are going to make us conceive the buildings differently. So, as for example, in this house, example of a passive house in Madrid, this house behaves as a whole from the thermal point of view because there's hardly a difference of one degree between one facade and the other, so different orientations. But the thing is, the heat recovery system takes care of all this, homogenizing the temperature in about 1 hour. So shall we consider comfort areas instead of comfort spaces from now on? So in conclusion, the external isolation due to passive strategies makes the internal strategy demands more consistent between spaces. Hence, we have less energy divisions inside the buildings. So new designs aim to establish open plan arrangements and spatial connections. So we are gonna see the buildings as a whole. My question here is, are we going towards space versatility, multifunctionality, and readaptability in terms of spatial arrangements? Thank you.
Cool. I'm Giancarlo. I'm going to speak about parametric graphic statics and designing and optimization of structures. But really what I want to ask is this specific question: what is the optimal configuration of atoms in my building, in our buildings? And to do that, I'm going to start with a simple kind of mundane engineering problem, which I'm sure will kind of delight you. So in this problem, we're trying to span it's a classic structural engineering problem. We're trying to span a distance and carry some loads. And we know from kind of our education and intuition that there are a number of ways of doing so. So there are a number of solutions ranging from the deep girder to different truss configurations. And all of them are valid structures, right? All of them are valid options. And indeed, there are more options, and all of them work as structures. In fact, there's an infinite range of options, and they all work as valid structures. The problem is that they're really not the same, right? They're really not the same. So when you look at this with a certain level of granularity at the at the specifics of the problem, and you start delving into, in this case, the structural weight, right? I'm a structural engineer. I'm interested in how much they weigh. That you see that there's a kind of quite the scatter. So the lightest one is less than half the weight of the heaviest one. And so given that, that large scatter, perhaps we should be pursuing kind of the different solutions with more vigor and kind of more curiosity. And indeed, when you start looking, maybe you ask me kind of, yeah, but they don't all move in the same way. They're not all the same stiffness. And the first point is that we don't always need that stiffness. And secondly, when you're looking at the truss configurations, sometimes the lighter options are also the stiffer ones. So there's not necessarily this correlation. And indeed, you can go lighter still with certain configurations, such as this one, which also happens to be the stiffest of the truss configurations. And this one is derived via a fantastic online tool available for all. It's developed in Sheffield, Bath, and Edinburgh called Layopt, and it does topological optimizations on the fly. And for those who want to find out further about these types of structures, you can look up Michel trusses, and you can find out more about the properties of these structures and their characteristic forms and why they are optimal. But going back to our options problem, I think the issue is that they often presented like this, and this is kind of a random image that I found off the internet, kind of just stuff that you can do. They're all possibilities, right? And without that level of granularity, we're not able to kind of discern between them. And this kind of, I think it happens right at the beginning when we're taught about these options, all the way through to when we're kind of proposing them. We need the level of granularity. And when you expand that to all the possible range of forms to three-dimensional structures, right, moving away from trusses, you end up with loads of different hybrids, loads of different types of structures that exist between the kind of the pure ones, and given a specific set of of things that you're trying to solve, different challenges, whether they're structural or others, there is always going to be some sort of optimal, right? It's just a case of seeking it out. Now, going back to the original kind of subject of the talk, which was kind of graphic statics, there is a kind of relationship between form and force that the trust problem suggested to us. And graphic statics is one of the tools at our disposal to explore it. Is one of the older tools, and it really involves the graphical representation of the forces acting within a structure, and it's kind of easily and intuitively understood, specifically kind of, or particularly with these catenary examples, but also as you move into different types of structures. And indeed, this was the way to design viable forms in the past, by drawing forces in equilibrium acting within the structure. And it's kind of really renewed interest in this. Famous engineers like Robert Myers in Switzerland use these techniques to great effect to develop kind of really celebrated and efficient forms. And kind of the explanations of why they're efficient forms can be found via graphic statics. I won't go much into it, but you can find, I've left some of the references in this case, the paper where you do that. But really, it's about balancing the forces acting within the structure so that you get consistent stresses throughout. Moving on, and kind of more recent research that I've been involved in, graphic statics is also kind of an excellent form finding tool. So we found that you can generate a whole kind of plethora of different structures, all in equilibrium, and kind of the analysis kind of it checks out. This isn't necessarily optimized, so this isn't close to our optimal configuration, but there are ways of doing it, and there are ways of getting into within graphic statics itself. But there are other tools too, such as this one. This is another topological optimizer, Peregrine. It exists within the Rhino grasshopper space, and this is information that I've found straight off their website. It looks at, it looks at solving a specific topological problem for a given structure, and others too, such as kind of maybe more familiar ones, such as evolutionary solvers like Galapagos and others, coupled with real-time finite element solvers like Karamba. And this all exists within the grasshopper space, and kind of we've used on various structures to test different options and kind of really explore the design space and find out what is this, this optimal that we're looking for. So kind of back to our question, right, that I think we should ask, and sort of why should we do this? Firstly, what is the weight of our buildings? Now, the reason to pursue weight and investigate weight is that these are the more elegant solutions, right? The lighter ones are slimmer, and they involve the use of less materials. And if you look at typical structures, right, just examples that can be found that are built, the scatter of weights kind of per square meter or whatever the unit is quite large. And so that suggests that we're really not looking at what the optimal is. We really don't know. And the other, of course, is the kind of the theme of today, perhaps the climate crisis. And I want to flag kind of these are the targets that have been highlighted by Letty, and they are enormously ambitious numbers, right? These are numbers that are really, really difficult to achieve, and that we're supposed to achieve over the coming years. And so we need every trick in the book. We really need to know the kind of, the optimal configuration of any sort of elements within our structure to reduce embodied carbon and to solve any of the other problems that were discussed today. And lastly, of course, cost. And kind of, I mentioned cost with some hesitancy, but cost is the thing that we use to sway discussions, right, and convince our clients. And we need to know this information. And we need to be able to optimize for it. And so kind of to conclude, what is the optimal configuration of atoms in your building? I hope I've convinced you to ask your engineers or yourselves this question. I think we have the tools to pursue and find the answer to that question. Thank you.
Hello, my name is Giles Bruce. I'm going to talk about persuasive sustainability, and I kind of decided to do this talk because I had an idea of something that we've all alluded to in today's very amazing selection of talks, but it's a hard one to discuss, which is how do you persuade the reluctant people that are, I suppose, part and parcel of making buildings happen. And specifically, I'm talking about clients. How do we persuade clients to actually make the kind of buildings which we're all talking about today? And I want to tell you 10 ideas or 10 principles which I have developed in my own practice, A0. And it's a small practice, so maybe the principles I have derived are not applicable to some of the much larger projects we've heard today, but I think maybe they are. Anyway, I'm going to share them with you and you can draw your own conclusions. Principle number 1, pick the right team. Architects do not make buildings on their own. We make them with engineers, structural engineers, facade engineers, mechanical consultants. We make them with contractors, suppliers. So many people go into the making of a building. This is one of the most fulfilling buildings I've built in the last 10 years. And I say fulfilling because we had an amazing team. The clients were inspired. They were really determined to build a passive house in an old cow shed that they owned. The contractor was amazing. He was precise, he was thorough, he was dedicated to making this building as well as he could possibly make. The mechanical consultant was amazing. Even the QS was amazing. He was absolutely on board in terms of helping us make the right decisions. And this is perhaps the most frustrating building I've worked on in the last 10 years. As it happens, it had the same contractor, who is still amazing. It had the same QS, who is still amazing. It even had the same mechanical consultant, who is still amazing. But this time we had a project manager who couldn't give a damn about passive house or any other related performance or maybe embodied energy or embodied carbon related discussion that I might choose to introduce. And because he had the client's ear, it made this project very much more difficult to kind of realize the level of ambition that I was able to in the previous project. So having a bad man in the team really brings the whole team down, and you end up scoring goals in your own net sometimes, which isn't ideal. Principle number 2, embed performance into design. This is O'Donnell Toomey's Central European University in Budapest, where I worked with them as a capacity of a consultant for passive design strategies. And it's an old building with a series of courtyards. And one of the things we did was we glazed the courtyards with these steeply pitched glazed roofs. This is the bottom of one of the courtyards, and this is the top. And this, as a design idea, kind of evolved through the design development. But as it was evolved, it was tested against many criteria, and from my perspective, many passive criteria. So this is this steeply inclined roof light. It's a way for light to get into the courtyard. It's a way for air to get in the bottom of that steeply inclined glass and through natural ventilation to ventilate at the top. It's a way, because it faces north, to minimize the solar gain that is instant on the glass. And it's a way to acoustically isolate the noisy students on the bottom from the director of the college at the top. So it does many things. And I think the fact that it does many things makes it perhaps more resilient to value engineering, because it's hard to look at this and say, you know what, it'd be cheaper just to make this flat. Because it does all those things, it's perhaps easier to persuade the client to keep it, which we did. Principle number 3, communicate complex concepts clearly. This graphic that I've borrowed for this presentation is a summary visually of the global temperature changes between 1850 and 2018. I think this is an incredibly persuasive graphic to tell a client why we need to care about these issues, because it very quickly and very clearly encapsulates a lot of data in one single graphic. This is a graphic showing the annual instant solar radiation on the Central European University project I mentioned. And very quickly, and I think very persuasively, it shows to a client how the orientation and the pitch of those roof lights minimizes the instant solar radiation and thereby their cooling load that is a function of solar gains. I think that's quite persuasive. This is a picture of a house in Brooklyn, which is a passive house. I think this is very persuasive to tell your clients, do you want a house that loses a lot of heat and all the heat that you put in just simply bleeds out the walls? Or do you want an incredibly well-insulated house that all the heat that you put into it stays put and you end up with a nice cold facade because your house isn't losing heat? I think that's very persuasive. Principle number 4, don't give the clients the choice about performance. By the way, I hope this isn't on YouTube. Anyway, we'll see. This is a project I did in Elephant and Castle for a client. It's 3 houses over a nursery. And when I was designing it, the client asked me questions literally every day for 5 years. He asked me about the brick spec, about the window spec, what shape the building was, why it was that shape, why it couldn't be a different shape. Many questions, and I'm happy to answer them because I think that's the role. It's a collaborative design. But never once did he ask the structural engineer questions. And never once did the structural engineer give him the option. The structural engineer didn't say, dear Mr. Client, how much would you like your building to stand up by? Would you like it just to be designed at the point of just falling down? Or would you like me to design a lot of, 20% margin on top of those minimums? I don't know what he did because he sized the steels and he decided the layout. And I think that's very interesting. And perhaps as architects, we should consider what we don't do. Why do we give our clients the choice about performance? Let's take the performance of an envelope, its U value. Why do we even make that an option? Why do we not design all our houses for passive house and then seek forgiveness afterwards? Why on earth do we ask the question? I don't. I just install the maximum amount of insulation and I don't ever ask because generally people don't think it's a question to ask. So a lot of the buildings that we do far exceed the minimums that the law says we should do, and whoever knows, I know. Principle number 5, make informed decisions, but don't necessarily tell everybody. This is a new build house we built in Camberwell in South London. There are 18,500 bricks in this house. And when we were picking the bricks, we picked them with care. We wanted to understand where they came from. We understand the claims of the manufacturers who made them. They're both certified bricks, and they both, as far as bricks goes, have, I suppose, credentials we want to incorporate into our buildings. But there are many other questions that we might want to ask. And in our 4th year course, we ask the questions of the 4th years to interrogate materials like this. And the kind of information I think you get from these questions is incredibly interesting and incredibly helpful in informing your decision. But I don't think perhaps it's necessary to communicate every single thing to the client. At the end of the day, perhaps all the client needs to know is what's the color and what's the cost. But I think it's important for you as an architect to know all these other things and maybe choose of all that knowledge what is important to communicate to the client who's engaging you. Principle number 6, find reasons not to make money the focus of the discussion. This is the destruction of the Haygate. And we've heard today how in this country, in the UK, demolition is incentivized through a 0% VAT, which means that if a client comes to you and says, I want to knock down my house or keep an existing one, then in fact, it's quite difficult to persuade them otherwise. So I had this in a house, it's on site at the moment, which is a house in Whitechapel. And we in fact got 2 planning permissions for the same house, one which was for a new build option and one which was a retrofit option. They both look exactly the same. There was no difference whatsoever in the planning drawings, but the difference is the retrofit option would reduce their budget by 20% because that's the amount of VAT they would have to pay. Now, as it happens, when we looked at the existing building, it's a small little house, and we looked at what we were proposing to do, we were able to make the argument that, firstly, there was enough of the existing to warrant its retention. See value in what you already have, the bricks that we leave in their place or the bricks that we can deconstruct and reuse. We also brought in the demolition contractor who looked at the site and said, this is going to be very difficult. There's no access. Your neighbors are going to kick up a storm and I'm going to have to close the road. And that might cost you £10,000. And the neighbors got involved and the party wall surveyor got involved. And in the end, the clients realized that perhaps, although the economic argument was strong, perhaps there are other variables to consider. And so they didn't knock down their house and they chose just to liberate all the materials and reconfigure them to design the newly adapted house that we currently are on site with. Principle number 7, if you have to talk about money, talk about time too. Some clients have no interest in carbon. I think that goes for developers, particularly. We are working with a few developers. This is one scheme that's on site at the moment in Rotherhithe for 6 units. And typically this project through this developer would have just been built with a steel frame, perhaps concrete. That's how he always works and that's how he would always build. But we were very clear we didn't want to do that. So we started conversations with various timber frame manufacturers and eventually were able to persuade him oh, I'm sorry, I'm at 8, aren't you? Eventually going to persuade him that, in fact, to go down a prefabricated timber route was in his interests because it could be made off-site, brought and installed very quickly, and fundamentally he could bring his units to market faster. So there it goes in, it's being installed as we speak. And I think what's interesting is from his perspective, that argument was based on time and money. But the other benefits in terms of reduced waste, in terms of using timber in lieu of high carbon materials are things that I know and I'm glad that I was able to persuade him toward. Right, principle number 8, perhaps be a sociologist. I don't do this much, but I think it's worth asking that all clients are humans, and they are sometimes a strategy you have to consider is maybe persuading them to be envious of somebody else's amazing green building, or perhaps making them appealing to their sense of pride. They might want a particular award or some certification which they can hang up, or perhaps they're just plain greedy to have the biggest PV array panel or something like that. But I think very often that as an approach is necessary to achieve the end of getting a green building built. Principle number 9, give the client a job. I think one of the problems I find very often is all clients can do is criticize and they can complain. But what you can do, I found, particularly, and we've talked about reuse, is a great thing to give a client to do, and this is mostly for domestic scale, is set them forth and tell them to find materials. Because if you go and tell a client, go find me stuff to build into your building, they come back with all sorts of things. They come back with, oh, this is it going? Oh, there, okay. They come back with old scaffolding boards. They come back with long lengths of glulam, which were lying in some sad corner of a timber yard. They come back with cast iron columns. And what I find really interesting when you do that is that suddenly when the projects get built, there's the scaffolding boards reused as structure. There's the cast iron column and the reused glulam beams cast in. These domestic clients, the only thing they talk about in their project are the things they found themselves. Everything else is irrelevant. So they've kind of invested this emotional level, which in a way is exactly what I want. I want them to reuse. Whereas if I was to bring a pile of old scaffolding boards, they'd look at me and say, no way. So I think it's very interesting that that's another way you can persuade people. Principle number 10, make it inspirational. That's what we do for a living. We have to make this conversation as inspirational as possible in order to make it happen. And that is what I try to do every day. Thank you very much.
Thank you everyone for your presentations / provocations. We have our respondents today, Eli Ferdin, Program Head of the Emerging Technologies and Design Program here at the IAA, Eduardo Rico, Program Head of Landscape and Urbanism at the IAA, and Theo Spiropoulos, Head of the DRL Postgraduate Program at the IAA as well. And also we have online Andrew Schoons, who is the Director of Ingenuity and the Engineering Club. Welcome everyone, and thank you very much for joining us today. I would like to hear your opinions or comments about any of these presentations that you've seen today. Theo, perhaps, would you like to start?
It seems like I don't have a choice, but I'm just teasing. I mean, it seems like in response to all the presentations in some sense, and within the context of understanding the terms design and culture, a big part of the aspects I think that was coming across is very much the idea of designing a strategy, not only to kind of make accessible some of the kind of technical challenges and let's say the larger kind of social mandates that we're putting on the table, but how in some ways to make that accessible in a way that somehow, at least in the last presentation, made people feel like they were part of something bigger than the actual explicit nature of the project. So I just kept thinking a little bit about a sentiment of a man named Victor Papanek. He wrote a book called Design for the Real World. And with that, he took a very strong kind of position about the idea of innovation and radicality, but he saw it as a social project. And he was very kind of critical of industrial and design in some sense, to the point where he basically saw it as a quite difficult kind of discipline. Part of it was to, in terms of communicate some of the so-called social responsibility. So in a long story short, in some ways, I think in terms of the ways that you guys approach design strategy as a way to somehow condition the ways that one thinks about performance design, engineering, space was brought up, planning, creative reuse. There are so many kinds of issues around it, which it seems to me like necessitate some form of synthesis that makes the challenges between like designing an individual building and thinking about an ecology of kinds of systems to be something that's really urgent. Papanek basically spoke about cross-disciplinary tool responsiveness as being a kind of key strategy for that. But in some ways, it was very much tied to the people also having agency to actually design their own things. So in terms of how one considers education, not only of disciplinary distinction, but also the client in this case, or the city, how do you guys see practice in that sense, kind of offering that in a way that is not so specific to a specific problem, but more generalizable in terms of a kind of statement of purpose, which I think some of the larger ambitions that everybody's trying to put forward. I'm mentioning that because the word culture for me resonates a lot. So if this becomes more of a cultural project, and I think everybody sees their commitment and agency in it, if it becomes a very disciplinary problem and we're only talking about engineering and design, it seems somehow that the mandate for some of the initiatives are somehow very difficult to feel that they're achievable. So I'm not sure if that's a question, it's more like a comment, but it seems to me somewhere between culture and strategy, there is a conversation to be had about what's generalizable, what cuts across all of the presentations today as something that somebody sitting in the audience could feel like, yes, I want to not just use Karamba or just think of myself in a digital design sensibility. I don't want to somehow revisit historical or vernacular architecture as an approach to a solution space. How do we somehow see that within the contemporary condition at the moment?
Thank you. Any comments?
Well, I was just going to add, if you can. We're all in the profession. I think we're all very clear on its complexity, and we all have our own little specializations and our own interests. But it always amazed me that everybody outside that profession, the product culture, don't appreciate very often that complexity. And so I think that what's really important is to find ways to bring as many people into the process as possible in a meaningful way. And I think what I mean by meaningful, I think design by committee is problematic, because I think there are reasons that people study so long to specialize, but at the same time, designing in isolation is even more problematic. And hopefully, I think what you're trying to do in bringing people into design is to make them value the built environment at an emotional level, so they feel like they have some connection to it. They don't feel like it's just some building to be used, disposed, and just thrown away. And I think that's kind of the mechanisms that allow people and the culture outside of just the profession, the disciplines, to become involved, either because they're in the building is incredibly easy to use, the building is incredibly intuitive, or they just love being in the building. I think they're the kind of buildings which somehow generate levels of interest and discussion outside of the profession of architecture and engineers. And you suddenly find buildings which people can't stop talking about them. And the one building, I think, I was involved in the O'Donnell Toomey Sauce Hawk Centre, and I visited it with Tom this year. I don't know if you remember Tom, but we had a conversation. We were just doing a little film. And a man stopped and said, "Who are you? Why are you here?" And I said, "Well, we're trying to make a little movie about this film about this building." And he said, "I love this building. I just want to tell you how much I love this building and all the things it does." And you suddenly realize that when buildings kind of create joyful spaces and create joyful engagement and create things that people want to be in, then I think people, the people who use them suddenly have a more critical assessment of bad buildings, and they suddenly create maybe their own benchmarks of evaluation and their own opinion about them. So I think that's really important. It all has to focus on how we connect to the people who use our buildings in the design phase and in the use phase, and not see them as this, you know, as architects who put photos of their buildings with no people in it. That's a problem. You know, they are for people.
I think the only thing that I would just mention is that because you spoke about persuasion, and in some sense within a client, which is, you know, having a one-to-one relationship with their architecture, that stakeholder is quite clear. But I think you also mentioned developers that have also their own kind of stakeholding strategies and their sort of benchmarks. And then you have also like public projects and governmental agencies. So that intimacy that we all seek in terms of appreciation for what we do may never really ever be the case when we're talking about scalability and issues. So the reason I was struck by your presentation in particular was about information that was meaningful to those different stakeholders. And that seems to me that it's not generalizable. It's very specific kinds of conversations with the varied people that you're engaging with. But in some sense, how do we operationalize that so that we don't talk about a team as just being a selection process, but embed more of that kind of architectural or engineering intelligence, performative intelligence within almost every kind of interaction. So it doesn't seem like we're trying to hoodwink people into paying more for a sustainable building, but we're really trying to develop a culture around the activity itself of design. And that's why I mentioned Papernik. He was very critical about the new, because in some sense it referenced its novelty as being something new. And that's why I'm very interested in the strategy part, because it seems there were conditionally very different scales of operation potentially and very particular stakeholders. And that's why I try to open it up from this perspective.
I would like to just point out the fact of having a collaborative design process from an early design stage, because it's not just about stakeholders, it's also about other disciplines. Because, for example, in terms of acoustics, it always comes late to the project. It's always an extra cost. And we were talking before about how to deal with these sustainable issues with the client, right? Less is more. I mean, the earlier, the better. We need to merge disciplines. We need to have multifunctional systems that solve different environmental problems inside the building. And we need to defend that in terms of cost. This is less is more. It's going to be cheaper. It's going to perform better. We are a team, and we need to go at every stage. We need to go together. So otherwise, we cannot design by our own, and then we will find the problem later. So yeah.
I like the way. Oh, sorry. I like the way you talked about. So you put together strategy and culture. In our case, I would change the word culture into context, maybe, but meaning exactly the same. We've shown 3 projects which are set in completely different context, in the wide definition of context. And this is always, so we do have a set of strategies as building engineers. They are, you probably understand them all. We work with light, we work with water, with energy, with structures. So those are the strategies. But which we will apply and to which extent always depends on the context, meaning the climate, the budgets, the client, the user, the regulations. Xavier mentioned that in Rwanda, so you talked about the water cycle. One of the reasons why the water cycle was so important in Rwanda was because you cannot throw water into the net unless it's clean. So that was, instead of being a problem, which it is in itself, it became a challenge. So let's do something. And finally, the client's very happy because he's got water stored and he's got beautiful plants on which were part of the cleaning strategy. Don't want to get into details. I just mean that we resonate with your words. So it's a set of strategies that always apply to a culture. And the broader that context is for us, so the more you have the local community on board, your client is on board with any environmental decisions that you can bring. Made me laugh with many, but they're also true. So the more you can have them engaged, the more you inform your building through the real climate, the real conditions, whether that means a regulation or a local problem, or that definitely makes the building. And the result, when those two merge together, is, you said something very beautiful. You bring you bring your building to an emotional level, not just to you as being proud of the result, but you engage so many more people, starting with the users, which is the main aim of architecture. So I agree with that tandem of strategies and culture, definitely.
We have Andrew Scoons online. Andrew, do you have any questions or comments?
Hi, yes. Well, I found it fascinating. I loved all the presentations, and thank you very much for that. I'm very interested in this discussion of culture. I've recently started teaching groups of professional engineers around the topic. I won't say we teach them culture, but we teach them around the topic of what culture is and how you interpret it. And we start off from the position of the literary critic, Terry Eagleton, who said that culture is one of the two most complex words in the English language, only equaled by its perceived opposite, which is nature. But the reason why we teach culture is because it was really a challenge by the great environmental engineer Max Fordham, who died recently, who challenged the industry really to say, in the sense that he said he wouldn't actually employ anybody who'd been taught as an engineer because they had all the culture knocked out of them. And so I think words are terribly important, and I would just throw out this thought, because a word that I think has been used a lot, but perhaps not as accurately as possible this afternoon, is the word performance. From the sort of literary world, performance in the world of drama is nothing until it is actually enacted on stage. Before that, it's just words on a page. And I think performance is a hugely important part of what we're talking about in terms of culture, because it adds in the idea of circularity to the information that becomes, once we measure the performance of a building, it becomes knowledge if it's fed back into design culture. So I just throw that out as something which I think is let's say, uppermost in my mind in the way that I'm talking with professionals at the moment. They have huge ambitions and ideas to design really well, but actually turning that into building performance that does what they intended is a far more difficult task.
Thank you, Andrew. Elif, would you like to comment, respond?
Thank you. Thank you all, first of all, for all the insightful presentations and the conversation. I kind of want to follow up on the points on culture and performance and the significance of performance. I mean, in MTech, as you might know, we employ, let's say, different tools and techniques for measuring performance, thermal, structural, so on and so forth, some of the aspects that you've touched upon. And I just want to start by saying that how much I appreciated Giles' point on don't give clients choice about performance, because it's really about data. And I think it's really about raising awareness that, these are not subjective choices, they're objective choices. So I would like to hear your opinion, maybe all of you, on that. And also, again, Giles, you mentioned about calculating the carbon footprint, one of the final projects that you showed. And I'm wondering, maybe again, you can all answer this, at what stage does that calculation come into play in your practice? The reason why I ask this is really because you might be aware, a few months ago, we completed a pavilion here on Bedford Square. And it was a collaboration between MTech and Hassel Studio. And they asked us to work with recycled timber planks. And so one of the first things we considered, obviously, aside from how to create something that is spatial and structural, but what is the meaning of using recycled planks? So how would they compare, for example, to using new planks or new kind of plywood? So we then came across a software, One-Click LCA. They also sponsored a project in the end that can be embedded, let's say, in the computational workflow from the initial stages. And we found that quite useful because that became in the end one of the, for us, one of the optimization methods for the final pavilion. So, how does, as I said, using new wood or new timber compared to using recycled timber, how much material can we use? But at the same time, how can we make it structurally sound and stable? So those were some of the, optimization parameters. So, it kind of led us to a new, let's say, workflow, and we are quite interested in, enhancing it further. So I'm wondering, how do you tackle with calculating the carbon footprint, when it comes to real practice? Thank you.
Yeah, I mean, there's a bit of a debate in our studio about how the best way to do it, but my own personal favorite way of doing it, and it's tied into my whole maybe attitude about how you use the word hoodwink. I don't know if I'd like to say hoodwink, but I think kind of make it easier maybe for the clients to embrace some of these things. So I found that sometimes it's easier to tender the project normally. Your standard structural members, your standard installation, to go through the system as it currently exists. And then you arrive at a contract value, whatever, £300,000, that's what your house is going to cost. And then at that point, you've got some time to say, okay, we're no longer talking about money. So let's leave that. Now, let's see if we can, within the contract, do better and measure against the baseline we gave ourselves. Let's take all the PIR insulation and swap with wood wool. Let's look at that from two questions, cost and carbon. We know how much insulation we need, we know how much carbon is in it, and we know how much we would save. And then I found that they can just about keep up where the clients then don't think their whole project is going to fall down because we're going down this environmental rabbit hole. No, it's fine. You have a contract. It's fine. Your contractor is going to start work, but we can piece by piece start to swap out the insulation, the concrete. Go and find me the reused columns. We have them anyway. If you don't find it, it's fine. We have something else we can use. But then I find that, and it's a very small scale project, I'd say, but I find that then you don't lose the trust of the client, because ultimately that's what it's about. Because if everything's a risk, and everything is always risky, particularly, the pavilion, I think, did you use packing crates, I think, was that it? Yeah. So the packing crates, you didn't know where they're from, But somehow I think giving the design insurance policy to say, okay, even if this fails, this strategy, your building won't not exist. So that's why generally in our office, we tender the building safely. And then when we're going a kind of a reuse route, we then deliberately try and swap out elements from the baseline of the contract and then measure against that baseline. Clients don't get stressed out because they think their whole building is conditional on some material resource we don't know we're going to get. The contractor's not stressed out because basically he's not taking the risk. If the column doesn't show up, he'll go off and buy the other one. Yeah. And somehow then it gets a bit exciting. Is it going to show up? So, and then the carbon, also the questions are, I mean, this is how I do it because I don't have the resources, but we then look at a component. What was the carbon of all the insulation? And now what is the saving? And that tiny little project with the reused glue lamp, we did all the carbon calculations for that, and it was about a return flight to New York of carbon savings. That was kind of nice to know, and just kind of the client, I think, then has a little bit of information and maybe a bit of knowledge, which they will tell their friends. Do you know, because we did this thing, that all these things, that's the same as you getting an airplane to New York and coming back. That's good. So I think, and that talks about, that is very accessible for a client. Carbon calculations are kilograms of carbon equivalent is not easy. But if you can find a way for them to buy into the service you're providing and the color of that service, the green color, then I think they will be able to disseminate that information beyond your remit to their friends, their families, etc. And then I think that starts to be perhaps more useful than a carbon calculation in just on a bit of paper somewhere in my folder in my project file.
In terms of performance, I think that buildings has something that other things doesn't have, which is that they need to perform 24/7 and the whole year, let's say. Every day, a building needs to perform perfectly. And that's the aim of every building. And this performance is absolutely related with the functionality and the comfort of the people that is inside. So whenever you define a building, you always need to think on the user and how it needs to work. So I think that that's very important. And in terms of the carbon that you were saying, what we do, for example, is that we put carbon and energy consumption to obtain this material or to use this material on the same level of cost, quality, and probably adding something which is quite interesting, which is the life cycle cost. Because some of these materials that performs very well in insulation, they disappear in 10 years because they don't last enough. And probably they are cheap at the beginning, but then they cost you much more. So for example, whenever you analyze GRC and GRP, GRP is very interesting for doing facades, but they are made in plastic and they are made in petrol, right? And they are very interesting because you can shape whatever you want, but at the end they last less than other materials. So it's not a good investment. And I think that just to inform the client, you can tell them, hey, come on, in the whole life cycle of this building, you will need to change it 3 times, whereas another one will last forever, okay? So that needs to put at the same level of carbon and energy, and needs to put as well at the same level of quality and cost.
Thank you. Just a question for Eduardo. Giancarlo proved that there is a relationship between the amount of material, geometry, and performance. No? So I wonder if you think the question of geometry, form, architectural style, it's important in relation to performance. Is there a specific set of architectures that perform better than others? For Eduardo.
Yeah. I was going to ask the question myself to the panel, no, like, because we can see. I'm not the absolute expert, but there is clearly a shift in the culture of the discourse in architecture. You can see hearing much more about recycling, reusing, that much more than before. Even though at the beginning of the boom period before the 2008 crash, you could hear a lot about sustainability, about optimizing buildings. But nowadays there's an extra effort on reusing, on recycling. And we can see that in the case of Elephant and MTech, they were merging that discourse with the reuse of the material and the optimization of the geometry. So clearly there's an extra layer that has been added. I'm not the expert here on discourses, but I think there's something going on. But my question, I think, to the panel is, to what extent is that really making a difference? I mean, how in the lifetime of our practices, how well can we persuade the clients that, yes, if we compare this building nowadays, it would be 10% better than if built 10 or 20 years ago. I think there was a chart in the in the presentation by Giancarlo, but it was showing how we are using less and less materials. Is that the case? Are we really making that difference? Let's say, would the buildings that we've seen in the last presentation take X much of carbon if they were built 10 years ago or whatever, or 20 years ago? And is the individually, but also as a collective, is the industry really going that way? Are we really, is that curve that Giancarlo showed true, or to what extent? I guess both in the structure and the optimization, but as well in the environmental, sort of like the M&E. Are our buildings really using 20% less energy than 20 years ago or whatever, as a aggregate?
So just to give you numbers, the average in London, I think that it's around 150, and now you can do buildings that are 0 in terms of consumption. I'm talking about kilowatts per hour per square meter, okay? But I think that the interesting part is to understand that the building,
even considering the, so consumption per year. So
so every year a building costs 150 kilowatts per hour per square meter per year, okay? Yeah. That's the average in London in terms of office buildings. And now you can do buildings that they consume 0 per square meter, okay? Yeah. Even if you, so considering that they produce part of the renewable energy, right? So you are moving from 150 to 0.
But there you are assuming that you are generating the energy in other means.
No. You can generate the energy on the building. Yeah.
Okay.
You cannot consider renewable energy from other places, right?
Okay.
So the building can have some part of production in the building in terms of renewable energy.
So your meaning is by the first reducing the demand, which is, the first thing is reducing the demand, which is a cultural thing and also, a sort of passive strategy. Yeah. So starting by maybe the correct orientation or the correct, so passive strategies, that's the first one. You're reducing the demand already, which is something that seems very obvious to some, but if we look at the buildings, it may not seem so obvious for everyone. And then, by sometimes using geothermal energy.
The way you produce the energy.
Exactly. And then finally, by using renewable energies, such as placing PV panels, for example, in your building, introducing them, whatever, you may actually produce an excess of energy that you can even put in the net. I guess this is the elaborate answer, right?
So my question would be, is that really happening?
Yeah, of course.
Like,
absolutely.
Is the industry being that good now?
Yeah. So the building that Anna showed, that she explained, that it's finished in 2012, just consume 43 instead of 150, okay? And the building in Madrid is 50. And the average in Madrid is exactly the same as London, is 150. So that is happening. But I think that your question, it's interesting as well, understanding that the optimization nowadays is not just on materials, is in materials and performance. So as Laura said in her presentation, we need to think the buildings as a volume, as something that occupies in the space. And this volume needs to be comfortable for the people that is inside. Sometimes the MEP is something that is patched on the building. And that's what happens when you are not integrating, when you don't have an holistic approach of the building. So the optimization, and probably that's something in the end that you can do, is to create volumes that performs much better in terms of materials and in terms of comfort.
And of course, that starts by spatial arrangements as well, because you need to, that starts by design, by the designer, not the consultants. Let's say, I always say the same thing. Acoustic problems can be avoided if you don't put a library just in front of a dining room, right? For a school, just change that. And everything will be cheaper and really easy to solve, no cost, no extra materials, you know what I mean?
And is that culture changed from 10, 15 years ago? Do clients listen more now?
Yeah, if I may, I think there is. And I mean, you can see it that we're kind of, we have a symposium about it. We have a symposium, kind of the theme is that, and it kind of resonates with the discussion we're having on culture before, that we can't underestimate the power of the big issues, and kind of, persuasion now comes by people buying into the big issues. And if you see it on both sides, like clients kind of, so not all clients, but many clients kind of asking for that now. You know, they expect the buildings that they occupy to perform to a certain grade. And also some of them are signed up to commitments that they have to perform to a certain grade. But you also find it on the other side that, young people joining practices expect it to be the baseline. They're not going to work with you unless you do that. So people buy into these big issues, and so I think hopefully the whole idea of persuasion on this specific thing, I think will get easier. Whether the industry is satisfying it in all aspects, I think certainly operationally, kind of the heating and cooling, they've made really big progress. I think to a certain extent, like the structural engineers are lagging behind. That it was, we always used to say 10 years ago, you'd say carbon's an issue, it's an operational issue. And because of the big gains made on one side, now embodied is a big issue. And it wasn't part of the discourse, 5-10 years ago, it just wasn't. And there is this drive now. And I think kind of just maybe kind of I've collected thoughts as people made their comments. I think when is the best time to measure it? There is different kind of, as an exercise of measuring carbon, you get different things that from measuring it at different points. So earlier on, sometimes the question then becomes to the client and to the design team, are you sure of what you really want? So do you really need to have, again, mundane example, those massive spans, do you really need 10 by 10 meter spans? If you imagine like the room that we're sat in now, that the much loved lecture hall with all its limitations, it's kind of, you adapt it to what you need as well. So there are a bit of those conversations that are happening too, sort of, are you sure you need that? And whether that's structure or the highest level of performance, the different sides to it.
Mm-hmm. I think I would like to go back to the idea of form, because we've been talking about spaces, cubes, but Giancarlo showed this idea. There is an algorithm that tells you what is the best shape to have a beam, no? But also there are softwares that tells you what is the best envelope shape to minimize solar radiation. So the question for me is people ready at all levels to embrace certain geometries and certain architectural styles, under the wave of the flag of performance? Yes.
Jessica made direct reference. I think maybe there's value in working out what an optimal is, whether you do it or not, and that's kind of to understand how far away you are from it. You're going to have other reasons, right? The project ambition is not to build an optimized structure; it's to build a good space to satisfy X criteria, and those other ambitions don't go away. But it's kind of, I think it's an important exercise in understanding how far away, or like kind of how much can I push that envelope? If I can't go beyond a certain number, maybe I shouldn't pursue this. And I think that's
Let me give you an example. Yeah. You present to a client, this is the beam you need. I don't like it. How do you argue with that? How can we collectively?
Well, I guess there's the basis of not liking it. The most common one is it costs too much. so the next step would be, okay, you don't like this one because it costs too much, but if we just change this, it's kind of quite good. Not the perfect one, but it's quite good, and it costs quite. It's kind of quite reasonable. Yeah.
I think that the industry needs to shift a little bit. And one thing that will change a lot is the passport of materials and the passport of buildings. So when the aspect, or when the answer is I don't like it, you will say that will cost you more because you are damaging more the environment. So for example, many people are saying that building in stones is very cheap for the environment because there is no impact. But come on, tell that to the mountain that has been destroyed. So how you go back, right? So if we are able to tell the client that the solution that we're giving him is the best for the performance of the building in the whole span life, that's the interesting part of it. Because if the client is just driven by aesthetics purpose, the industry never will change. And here is the point. So we need that someone in the government or whatever it is called, put this way of value things because of the damage in the environment. And now it's just happening. Companies like Amazon or Google or all these companies, they are paying taxes in carbon emissions. So they are rethinking their sheds because they want to offset all these CO2 emissions as much as possible. And that's the point. So if we enter to this area, for us, it's like a way to escape, you know, and to do the right projects. Because if not, you are always debating with the client, you're always in discussions, and you're always in these kind of areas that I don't like it.
Just, I mean, one of the things though that seems to be a little bit concerning is the reliance on comfort and the reliance on code, because it seems to me it somehow takes away agency to really challenge the building sciences as is. I mean, I can imagine not too long ago when I was a student being taught Trombe walls and being taught all of these other things. I didn't know about people like Eladio Dieste. I didn't have these other kind of alternative models that were working with kind of local responsiveness, the labor, kind of inventive, kind of new sort of paradigms to make bricks, you know, fly in a certain sense and find kind of hybrid uses. Because at the moment, for example, if we take the contemporary cultural conversation around these subjects, everything should be CLT. And we should never touch concrete again. And I think that the level of the conversation sometimes becomes very problematic because the level of the conversation starts to speak about quantifiable data, but data also has agendas and is being deployed in very different ways, because a lot of the things you mentioned was about the comfort of the user. Which is very different about also the aesthetics of so-called greenwashing and things like that. That's also just as much an aesthetic condition as it is anything to do with performance. So I think when it goes into the conversation about what's at stake, I think the question about using tools like graphic stamps and all of these other tools is to also employ a kind of more experimental way to develop solution spaces for some of these problems. The question is that it may demand a new concept of aesthetics to be evaluating those things, which is not an issue of like or don't like. It may have a lot of the issues that you guys are talking around the table, but I don't think it would have a reliance on comfort and on code, because I feel like that's the same thing like energy rating of the building that I'm in 16 Morwell Street. It's a terrible building, but I don't need the energy rating to tell me that. It's a terrible building for all sorts of reasons. And as much as it is about spatial and human comfort, it's also about performance, which I think Andrew is not here anymore, but I think put a very interesting kind of dilemma on the table. We talk about performativity and optimization as almost like post-rationalizations, but unless that's deployed with a certain knowledge, you can't optimize something that has no kind of rule-based logic to begin with. I mean, you can value engineer something and somehow give it some legibility in terms of those terms, but to truly be able to employ those tools means an upgrade of knowledge across tools. And I'm just wondering, in terms of the ways that you guys are speaking about it right now, like, where do you think the agency with that lies? Because in some sense, we were always somehow responding to the tools that were at play to deal with the complexity. Now we have a digital culture that should make that shared and more accessible kind of terms of engagement more dependable, to be more generalizable and more applied and operational. But that conversation doesn't seem to be holistically. And I think you spoke about the kind of holistic and correlated way of thinking about systems, but it doesn't seem in practice that you may be an exception, but generalized practice doesn't have this conversation. The team that's put together is usually a kind of afterthought of relationships to respond to a brief that, to be honest with you, may be part of the problem, the way that the brief has actually been put together by a government and so forth. And this is where I mean, like, symposiums like this is very important, but just trying to find ways to forge more forcefully agency to people that actually have the knowledge to be able to deploy it seems very important, because it doesn't seem that progress is going to come from the industry. The industry is actually the thing that doesn't really enable a conversation like this to truly be operationalized in some ways. At least this is my limited experience, but the word comfort, I think you're using it in two ways. The one way I totally understand it, but I also think the way that people engage in the everyday will have to radically change. So the issue of comfort may not be the thing that's more primary. It may be a radical, just different idea of how we live and what our new comfort may be. Otherwise, we wouldn't have all of this glass box buildings with blasting air conditioning. And I'm just saying it's a very complex issue. And I love a lot of the things that everybody's talking about. But language for me sometimes limits, I think, agency in some way. And I'm just curious on how you guys are thinking about it, because I can see it in each individual practice. But I think the question is, it makes certain assumptions that we got to figure it out. And maybe we have to really radically explode the search space of form and performance and material so that it goes beyond, let's say, an applied kind of aesthetic. You know, if Kanye uses CLT in a video or something like that, then somehow it's appropriated as a new aesthetic, but nobody would look at plywood flooring and think of it like that would be a finish that I would somehow maintain. It's somehow these things are changing very much with the culture of how design is appropriated. So it's just something to put on the table. So.
Thank you very much, Seal, because I think that's always there. I think that many of us, what are trying to do is to create this seedbed in the AA, where there will be many of us trying, many of us bringing contributions of various aspects, not all of them, of course, but all these. I mean, you see it today from, this is the fourth table, but I think everyone has actually brought a contribution. Now, I think the sum of all those probably is actually going to make this culture change, right? So long as we all keep on trying. I think that what I find most encouraging is that there has been a culture change even in the AA. We wanted to do this many years ago, and it's only happened this year. I think that's telling, right? But besides that, I think that, can you imagine when, all these has been year in, year out, developing further and further and further. So there will come a moment where everyone will recognize the effort that person has actually brought in and the contribution they've made. I think, I've mentioned earlier this morning that, there's an element of the Pied Piper of Hamlet. If we make it, if there's enough success here and there, if it is beautiful enough, if it is convincing enough, is what I kept on laughing with Giles's contribution. On top of that, they were actually, in the way it approached it, it was very attractive. There's nothing more attractive than a good laugh. So I think that if all of us actually keep on trying, I think it will happen. But that's one view.
Just confirming what you're saying. So yes, there are two words of comfort. One comfort is the people that is using, and the other one is the one that is set up by the regulations. And I invite everyone to challenge this comfort. And I think that's a clever way to upfront a building. So for example, what Anna explained, the building that is in close to Barcelona, this building is challenging the comfort a lot, because only on the main boxes where the tubes are is where you can find the comfort from the regulations, but the other spaces are absolutely open to whatever happens with the greenhouse effect, okay? And that's something that whenever you work at this building, you sign off a paper saying, I accept these thermal conditions. And that's something that you can only do with some clients, not with everyone, at least now. And I want to say that because I did a seminar in very low carbon structures, I would say 6 years ago, and we were 6 people. We did one last year and was 250 people. So that's the kind of things that are changing. And I think that the academia or the universities are responsible for that. But honestly, the first one that needs to put a stone on the table is the governments. The governments need to change everything. So we cannot have an advantage of demolishing a building of 20% for a building that is refurbished. So that's ridiculous. And that needs to change yesterday, not tomorrow. So all these things are changing. And I think that the way we understand the comfort is something that needs to shift a lot. So we don't need this level of vibrations on the buildings. We don't need the level of temperature, because as we commented yesterday, most of the comfort, the thermal comfort and the regulations are thought for a man that is dressed in a suit with long arms and a jacket. And that's ridiculous in summer. And in winter, you can be a little bit more warm. So all these things need to change a lot. Okay.
It's evident in your work and when you present it, and I'm sure you could have many different conversations about your work. This is one of them. And I think it seems to me the more that we make it like this is a form of, sustainable or performance design, it connects to a kind of conversation that connects to the things that people relate to, which is aesthetics or a kind of attitude towards culture or responsibility. And those waver quite a lot. And the only reason I'm mentioning that, I have a colleague who's working at ETH who is also involved in looking at concrete, but there's some of the same algorithms to try to understand, like the slab doesn't have to be this flat pancake piece. We could start to use some of these technologies to really be very specific about material placement and performance, and that makes a demand that the architecture in its true state is a hybrid systems, hybrid strategy, and like you mentioned about context, that context awareness plays such a critical role, not only for it to be created and produced, but also to be accepted. And I think in this acceptance, it seems like the idea to version and to be, let's say, more scientific about it has to be coupled with the more cultural aspects and the social aspects of living, because what you're mentioning is actually taking a risk, because it assumes that people will understand their social responsibilities and potentially buy into it. But if it doesn't, so there is risk, which I think is an important thing to maybe get across, that it's very important that we take some risk in terms of trying to problematize actually the approaches to these issues, which I think are not going to be standard across the board.
But something I must say, maybe to wrap up.
I'm conscious about time, so if we could wrap up.
I could make it in a wrap-up way, which is what we have found from working in this holistic way, because we are, in our work, we are the structural consultant, but also the MEP, but also the bioclimatic and sustainability, which gives us, we're lucky, let's say, a holistic approach. And what we try to do is give the designer, which is the main person who decides, about the project. What we've seen is that if you take the right strategy for the right context, you give them, you put them on the table, you will never, so the best building, or the building that comes up from all those strategies, is never the one that has the most optimized structure with the best passive strategies, with the minimum active MEP and the most, all the biophilia and bioclimate. That is probably very ugly. With the optimized shape given by a software, that's all of a sudden have a muffin in our head, right? So what if it seems to us, or at least from our work, we've seen that when you provide all the strategies that are in place, but the context, the user, the client gives you the right ideas, the designer, of course, okay, the structure is important because it needs to sustain a building, but actually this is such a harsh climate that maybe the facade should be the one maybe taking a step forward. And so if you adapt all the architectural strategies that we all know, and you adapt it to that precise context. And the context is not only the climate, it's the moment. We're in the 21st century now, and we've got a context different to 100 years ago. We've seen that the buildings are, what did you call them, emotionally, they end up being, exactly. So maybe we've been lucky, but this is what we've seen. You provide many strategies, or you think of, the right strategies for the place, and then the context, the client, especially the user, ends up, shaping the best architectural result.
Okay, thank you very much, everyone, for joining us today. Thank you, speakers. Thank you, respondents. And that is the end of the ETS symposium. So far, climate practice in terms of climate crisis. Thank you all very much.
Thank you.